Is the planet beneath their feet merely a chunk of rock turning in the cold arithmetic of the solar system, or is it something else entirely, a living, sensing entity with its own inner life? That question sits like a small, persistent pulse in the chest of human curiosity. It is simple enough to state in a single breath, and enormous enough to unsettle the foundation of how humankind understands its place in the universe. The notion is not a neat scientific hypothesis to be accepted or rejected with a single experiment. It is an invitation to look at time, matter, and life with a different kind of attention, one that measures depth as much as distance, rhythm as much as position. The voice that poses it is not searching for an answer so much as opening a horizon. If the planet itself bears some form of consciousness, then what is the status of everything living on it? Are human beings incidental hitchhikers, transient patterns of metabolism, or are they threads in a much larger tapestry of planetary thought? The image that follows this question is not cinematic in the conventional sense. It is not an orbital shot of continents and cloud bands. Instead, it is temporal, a compression and stretching of time so that millennia and heartbeats sit near one another. Imagine the Earth's 4.5 billion years reduced to a single day. Dawn would be the molten haze, the first cooling crust cracking like the shell of an infant world. By noon, continents would be shoving and shearing across one another, mountain ranges thrusting up like the planet flexing its muscles. Evening would be marked by ice and warmth in slow alternation, oceans rising and falling as if in respiration. In that day, modern humans would appear in the last minute, a flicker of conscious noise on an otherwise vast, ongoing process. That image gives the initial emotional contour. Human life is immediate and bright, but it is also temporary and small compared to the rhythms that cradle it. Yet size and duration are only part of the question. Consciousness, as commonly imagined, arises from a network of interacting parts, neurons firing, hormones fluctuating, feedback loops, establishing patterns that persist through time. On a different scale, the Earth also hosts networks and feedbacks. Plate tectonics recirculates rock and minerals, shuffling the chemical deck. The atmosphere exchanges gases with the biosphere, adjusting the composition of the air with every photosynthetic breath. The oceans store heat and redistribute it with currents that span hemispheres. These systems remember and respond. Their histories are recorded in sediment layers, isotopic ratios, the grain of minerals, the trace fossils that preserve an organism's last movement in stone. To speak of a planet's mind is to borrow metaphors, but the borrowing is not frivolous. It maps the shape of complex, coupled processes onto something more apparent, a body that learns, reacts, and evolves. For those who have long moved between the hard maps of geology and the softer maps of biology, this is not a new conversation. The Gaia hypothesis, first articulated in its modern form in the 20th century, proposed that the biosphere and the Earth's physical components form a self-regulating system. The idea itself was provocative then because it suggested a kind of homeostasis, surface conditions stabilized in ways that favored life. But the rhetorical power of the phrase, the Earth as organism, has always exceeded the technical precision of the hypothesis. It is not necessary to anthropomorphize a planet to find the metaphor useful. It suffices to recognize that life and non-life engage in an endless negotiation that shapes atmospheres, climates, and the chemistry of the sea. If the planet possesses a nascent or distributed form of awareness, its senses would be nothing like human senses. There would be no eyes that focus or mouths that speak. Instead, sensing might be distributed across ionic currents in the ocean, a slow whisper of mantle convection, the global choreography of microbial life. A change in the composition of the ocean for thousands of years could be a long, low signal, a rumbling in the Earth's tissues analogous to a cough or a shiver. The magnetic field might function as a nervous scaffold, linking far-flung processes through guiding particles and protecting the fragile skin of the biosphere. Lightning, volcanism, the bloom and crash of forests, these could be pulses and flares. If a planetary mind exists, its time signature would be a blend of the immediate and the geological, sudden eruptions and gradual weathering, both meaningful in ways not immediately accessible to a species that lives in decades. That leads to the unsettling idea of memory and erasure. The Earth's archive is both abundant and deceitfully incomplete. On one hand, strata of sediment, banded rocks, and fossilized life are vast libraries. They tell of deep freezes and torrid swamps, of great sea levels and vanished inland seas. On the other hand, the planet is adept at forgetting. Subduction grinds entire ocean floors back into the mantle. Erosion smooths away signs of past landscapes. Metamorphism transforms once readable pages into unreadable slates. This duality, the ability to record and the ability to erase, creates a peculiar epistemic situation for any civilization pondering the past. It is entirely plausible that episodes of complexity, even technological activity, could leave traces that are subtle and easily masked by natural processes. Chemical anomalies might persist, but only if the processes that produce them are rare enough or the signals strong enough to survive billions of years of mixing and transformation. Speculation about lost civilizations is part of the human imagination because it fits the narrative of hubris and anonymity, that great enterprises can be swallowed by time. But the question implied by the opening idea is different in scale and in kind. If the planet itself has agency or awareness, then humans are not merely potential chapters in a history that could be lost. They are possibly akin to cells in a larger organism. This analogy is at once poetic and provocative. It reframes stewardship as not merely an ethical duty toward other beings, but as a relationship within a living system. If a skin gets infected, the organism responds. If certain metabolic processes run amok, the organism may enter a fever. To think in these terms is to contemplate the possibility that climatic upheavals, mass extinctions, and recoveries are not only physical events, but also episodes in a planetary life cycle. That idea generates a spectrum of emotional responses. There is wonder. The thought that the world might be more alive than it appears invites humility and awe. There is fear. The planet's moods could be dangerous, indifferent, or corrective. There is comfort, too. If the Earth has patterns larger than human ambitions, then individual losses and triumphs absorb into a broader continuity, easing the existential pressure of finitude. Each of these effects carries moral consequences. If Earth operates with a kind of agency, human attempts at control or exploitation take on a different cast. They risk being not merely environmentally destructive, but also relationally discordant. Conversely, human cooperation might be seen as a form of healing or symbiosis. Emotion aside, the practical challenge is how to test for planetary-scale awareness, or even to recognize it. The modern scientific toolkit offers measures and patterns, long-term stable anomalies in isotopic ratios, synchronous, planetary-scale biological responses that cannot be reduced to local causation, persistent electromagnetic patterns with non-random structures, and the kind of information locked in non-volatile, globally distributed markers. Yet all of these are confounded by the Earth's tendency to erase, mix, and transform. For example, an electrical signature produced by a coordinated biological event would be ephemeral and easily drowned in the planet's background noise. The signature of a past technological society might be embedded in deep sediments, but tectonic recycling could have obliterated it. The problem is both observational and ontological. How does one distinguish between natural complex processes and processes that ought to be read as signs of an emergent mind? This is where the documentary mind must tread carefully. The temptation is to fill the unknown with narratives that satisfy the human craving for meaning. The better strategy is to treat every possibility as a path rather than a conclusion. One path is to expand the definition of evidence, to search for patterns rather than single artifacts. A second is to reframe communication. If the planet is a form of intelligence, communication may not be discrete messages, but shifts in probability distributions, a move in the planetary state space that increases the likelihood of certain kinds of life or climes. Recognizing such moves requires an attunement to long rhythms and a discipline in reading noise as signal. It also requires humility. The planet's modes of expression could be alien, literally incomprehensible to neurons and social habits evolved under shallow time scales. The anthropological dimension of the question is unavoidable. Humanity's myths and religious systems have long hinted at a living Earth. Folk tales personify mountains and rivers, and many indigenous cosmologies describe intimate relationships with place that conflate spiritual agency and physical processes. These traditions are not scientific evidence in the modern sense, but they are experiential archives, ways in which humans have lived as if the earth beneath them carried intention and voice. To take those experiences seriously is not to accept them as literal proofs, but to enrich the palette of hypotheses and to remind the investigator that direct perception and long-term association can encode knowledge complementary to laboratory data. And then there is silence, the absence of a detectable planetary mind. That absence would be meaningful too, though in a different register. If the planet is fundamentally inert, a massive stage where life and mind occasionally appear and then vanish. Then the task of responsibility falls squarely on the transient actors. Stewardship becomes finite, urgent, and solitary. The moral calculus is simple and stark. No external steward will correct excesses. The burden is human and human alone. If, conversely, the planet exhibits signs of distributed awareness, then the ethical calculus expands to include forms of listening, translation, and negotiation across vastly asymmetric timescales and forms of agency. Both scenarios are heavy with implication. Either humankind must learn to govern itself wisely, or humankind must learn to relate as a constituent part of a larger life. The narrative implied by the opening question is less a proposition and more a trajectory. It is a way of reframing inquiry so that the lens is not solely on human-centered value, but on planetary processes as potential carriers of mind. That reframing demands new languages, metaphors precise enough to be useful, but flexible enough to hold mystery. It also demands humility about methods. If the Earth communicates in timescales that dwarf human histories, then listening requires patient accumulation of data and the cultivation of interpretative frameworks that honor deep time. At the end of this first reflection, the open-endedness is the point. Curiosity does not seek closure in a single answer. It seeks a map of questions that can guide examination. The planet as consciousness question is an invitation to extend senses outward and backward in time, to read rocks as texts and climates as moods, to imagine human history as a brief, bright filament braided into geologic tapestries. It is an invitation to feel small without succumbing to despair, to recognize the fragility of human institutions and the durability of planetary systems, and to imagine relationships that are reciprocal rather than exploitative. Thus the series begins with a question that balances science and story, skepticism and wonder. It asks for careful listening, for attention paid not only to high-resolution satellites and isotope ratios, but to patterns that play out over millennia. It asks for moral imagination, for considering how actions that seem temporally localized might reverberate across the slow symphony of planetary life. Above all, it models a posture toward the unknown, one that combines the rigor of investigation with the humility of someone standing next to something much older, larger, and possibly aware, and asking, in the oldest human way, what it might mean to live inside its embrace. What does it mean to be born inside a star's shadow? What would an origin feel like if origins could be felt at all, not as a single instant, but as a long, violent becoming that stretches across millions of heartbeats and billions of years? This is the image that opens the second act. The Earth is an embryo, swollen with potential, warmed and shaped by the sun, buoyed in a cosmic womb of dust and light. It is an idea that insists on scale and on sensation at once. It asks the listener to compress and extend time, to hold a child's first gasp and a planet's first convulsion together in a single thought. The beginning is a storm of matter. From the calm of interstellar space, a cloud of gas and dust collapsed inward under gravity, eddies and filaments spun, and within that spinning sheet of material, small concentrations, planetesimals, met and merged. These were not orderly unions. They were collisions, shatterings, recombinations. Each merging was an act of violence and creation. Kinetic energy converted into heat, rock softened into a global magma. The embryo that became Earth grew by tallying up these encounters, its mass accumulating until its interior glowed red with the friction and compression of accretion. There is a kind of cruel tenderness to this early act. The sun, still young, poured out a bath of photons, a steady stream that both nourished and stripped. Solar radiation baked the surfaces it touched and drove chemical separation across the burgeoning planet's outer layers. At the same time, the sun's early wind, a gusting flow of charged particles, pushed against nascent atmospheres, peeling away loose gases from smaller worlds and sculpting the boundary between hold and loss. In this heated exchange, the embryo learned the simple rule that would govern its future. Energy could be a life-giver or a thief, depending on the state of the sheltering body. That shelter, at the core of the narrative, was not simply a ball of rock. As metallic iron and nickel sank toward the center under gravity, they liberated heat and organized themselves into distinct layers. The descent of heavy elements built a dense core and left a silicate mantle above it. That differentiation was a first act of internal organization, a segregation that established contrasts, hard and soft, cold and hot, conductive and insulative. The moving metal at depth would later become a dynamo, generating a magnetic field that, in the grand story, would function like a primitive nervous scaffold. It would not think in the way biologists understand thought, but it would create a condition, a shelter against the relentless stripping of charged particles, a parameter that allowed volatile compounds to persist and oceans to form. Violence returned with a particular, infamous climax. In the later stages of accretion, a body of substantial size, often dubbed Theia in scientific reconstructions, collided with the young Earth. The encounter was cataclysmic on a planetary scale, advancing massive impact that excavated and ejected enormous amounts of material into orbit. In the aftermath, a disk of molten debris circled the planet, and from that debris, the moon coalesced. The moon's formation was not only a dramatic moment of production, but also a functional turning point. The new satellite would moderate tides, stabilize axial tilt over long spans, and thus influence the rhythms that shaped climates and the cycles that living systems would later exploit. It was, in other words, a formative step in the choreography of conditions that made persistent surface water and long-term climate possible. Heat lingered. For a long geological time, the surface was molten or bathed in dense superheated atmospheres. No breathable sky hung overhead, only heavy shrouds of gases expelled by volcanic outgassing and supplemented by volatile deliveries from comets and carbonaceous asteroids. Water, trapped as vapor and ice in the infalling material, remained a potential rather than a present ocean. As the planet gradually lost heat through radiation into space and the release of internal energy via conduction and convection, the first crust began to stabilize in patches. These were thin-scabbed at first, fragile rafts of solid rock on a sea of magma, but they were important. The crust allowed a separation between the planet's convective interior and the external environment. It set up gradients, differences in temperature, composition, and structural integrity. That would become the substrate for future complexity. Imagine, for a moment, what the early Earth felt in the language available to humans, not feelings, but a succession of gradients and fluxes. Heat flowed outward, volatiles exhaled from the mantle in sulfurous plumes and carbon-rich vapors, heavy metals sank and formed a dynamo that generated a protective magnetic cocoon. Lightning arced through dense skies, catalyzing chemistry and flavoring the air with radical species. Tidal currents, governed by the newly formed moon, began to drag and pull in the shallow margins, creating energetic interfaces between crust and sea. These were not sensations in a homuncular sense, but they were persistent, legible processes, the planet's early ways of interacting with its environment and redistributing energy. Water's arrival marked the transition from embryo to an emergent body with surface processes that resembled metabolism. As the planet cooled enough for steam to condense, rains began to fall in sheets, filling basins and knitting the first oceans. Water is a remarkable medium. It dissolves and transports, it buffers temperature swings, and it supports gradients in salinity and chemistry that can be exploited by chemical systems. The presence of liquid water allowed for exchanges that were both local and planetary. Hydrothermal systems, plumes venting from the sea floor where the mantle met the ocean, created hot, chemically rich environments where mineral-laden fluids met cold seawater. Across millions of years, such places served as crucibles for complex molecules, offering energy fluxes and redox gradients that could, in principle, power the emergence of metabolism. The sun's role during these processes was paradoxical. It was a life-enabling, steady inflow of energy, and yet it also posed a challenge. Ultraviolet light bombarded the early surface, breaking bonds and creating reactive species that could both promote and destroy complex chemistry. But the young planet was not helpless. Its newly stirring magnetic field deflected high-energy particles, and as the atmosphere thickened with greenhouse gases, surface temperatures found a balance that permitted long-term liquid water. The tug-of-war between incoming stellar energy and internal planetary regulation set the temporal framework for stability and instability alike. If the embryo's early history is a sequence of energetic and structural events, it is also an archive of tiny, remarkable survivors. In the detritus of cooling crust and the washes of early rivers, minute mineral grains, zircons, for instance, formed and stubbornly endured. These crystals are like geological seeds of memory. Locked within them are isotopic ratios and trace elements that record the temperatures and fluid histories of their birth. In time, such robust fragments would allow far future investigators to read the conditions of Earth's infancy with the patience that the planet itself had required. These minerals are testament both to resilience and to erasure. They endure because they are chemically tenacious. They are rare precisely because most early surfaces were recycled or destroyed. That recycling is crucial to the narrative. Planetary memory is not a simple linear record. Plates of crust would later collide and sink into the mantle. Oceanic floors would be remade and swallowed at subduction zones. Erosion would smooth and obliterate features. Metamorphism would rewrite mineral histories. The planet's knack for forgetting is as important as its capacity to remember. Where memory persists, it does so by selective bias. Certain chemical or physical signatures are preferentially conserved. Where memory fails, entire epochs can be rendered invisible. This pattern has immediate consequences for any attempt to reconstruct the deep past. It suggests that the early epochs are best read through resilient proxies and through the logic of processes rather than through intact, contiguous narratives. The embryo's development also involved a coming into sense, establishment of global circuits that could transmit disturbances and feedbacks across long distances. Ocean currents began to carry heat, salt, and dissolved minerals from one hemisphere to another. Atmospheric circulation, driven by solar forcing and planetary rotation, redistributed energy and moisture. The nascent magnetic field channeled charged particles and guided ion flows. In later terms, these circuits are the planet's physiological systems, heat transport that resembles circulation, chemical gradients that function like metabolic differentials, and protective fields that parallel immune responses. None of these systems imply consciousness in the human sense, but they do imply a form of functional connectivity, a capacity for the whole to respond to perturbations in ways that shape future states. Within that connectivity emerges a quiet, accumulating tension, the interplay of novelty and stability. Life, should it arise later, would be an expression of novelty, exploiting the planet's tendency towards stability. Chemical systems that harness gradients, the difference between hot and cold, acid and alkaline, reduced and oxidized, could organize matter into persistent patterns. But even before life, the planet exhibited a propensity for self-organization. Convection cells within the mantle patterned the lithosphere. Mineral terraces precipitated from supersaturated waters, rhythmic. Tidal sloshing etched terraces and coastlines. These patterns were, in a profound sense, the planet learning the grammar of its own dynamics. The image of Earth as an embryo is not merely poetic. It is a way to render visible the sequence of formative mechanisms, accretion and differentiation, impact and satellite formation, outgassing and condensation, the establishment of magnetic and circulatory systems. Each mechanism contributes to a condition that favors or disfavors the persistence of complex chemical systems and, later, life. The sun's steady light becomes the metronome, the moon's tidal forcing establishes periodicity, the core's dynamo shields and structures interactions. The oceans serve as both mixing bowls and selective membranes. Together they build an arena in which complexity might not only arise but endure long enough to leave a trace. Yet the artist responsible for the scene is also a destroyer. The same processes that create habitability also erase its earliest signs. Impacts rub away surfaces. The relentless churn of plate tectonics recycles the crust. Atmospheric and oceanic processes blur the lines. This duality, creative and destructive dynamics interwoven, shapes the epistemic problem facing any later interpreter. How to separate the planet's energetic background from the faint signatures of incipient life or even the echoes of prior episodes of complexity. The embryonic Earth writes with both a broad, noisy brush and a fine, selective hand. Detecting the latter within the sweep of the former requires frameworks attuned to long timescales and to resilient markers. By the time the first oceans had settled into something recognizably oceanic, by the time the crust had cooled enough to host persistent landforms and shallow continental shelves, the planet had already enacted a vast inventory of experiments. It had tried many chemical permutations, established physical gradients, and built feedbacks that would both enhance and constrain future trajectories. The stage for life, if life were to take root, had been prepared not in a single miraculous instant, but through a long elaboration of structure and flow. This is the emotional texture the documentary voice must convey, a sense of wonder at the scale and intricacy of planetary formation, an undercurrent of unease about the fragility of emerging conditions, and an abiding curiosity about what records of that early becoming have survived. The origin is both banquet and gauntlet. It invites the listener to realize how contingent habitability is, how dependent life would be on a sequence of fortunate, convergent processes, a magnetic shield, a tempering moon, the right inventory of volatiles, long-lived oceans, and a crust capable of forming and reforming productive interfaces. And in that realization lies a moral weight. To imagine Earth as an embryo is to imagine oneself as an extremely late arrival in a story of protracted formation. The human mind, which has been taught to think in decades and centuries, sits like a single cell within an organism that matured over timescales unfathomable to ordinary experience. That perspective does not diminish human meaning. Rather, it reframes responsibility. One consequence of seeing the past so broadly is humility, the understanding that the conditions that allowed for human life were neither inevitable nor permanent. Another consequence is a haunting question that the next chapters will press. If the planet is capable of organizing and reorganizing itself over eons, what paths remain open to species that have learned to perturb those long-term dynamics with unprecedented speed? The embryo phase is over once the planet establishes persistent surface conditions and the circuits of interaction are in place. But the echoes of that birth, the memory traces and zircons, the fingerprint of the moon forming impact, the patterns of mantle convection, remain. They are both evidence and warning, evidence of the complex processes that made habitability possible, and a warning that those processes are slow and often unforgiving. The next part of the story will follow how those early structures, born in fire and light, became the scaffolding upon which chemical precursors might assemble, and how the young Earth continued to feel and respond to itself across the hush of deep time. For now, the listener is left with the grandeur of beginnings, the image of a planet as an embryo warmed by a star, its first senses forming in gradients and fields, its early memories written in hard crystals and layered sediments, and its capacity for both creating and forgetting already present in the same motions that made it. What, in the end, is a heartbeat on a planet? It is not a pulse that a single ear can hear, nor a drum that marks each passing minute. The question itself is a lens. It refracts the familiar language of bodies into the scales of rocks and ice, and asks whether the thermodynamic choreography within Earth might constitute a kind of living rhythm. If one accepts the provocation only as metaphor, the image still matters. The molten iron core hums with motion. The planet's field of forces and flows creates repeating patterns that could be read as pulses. To listen is to change the scale of attention, to trade human lifespans for epochs, and to translate temperature gradients, seismic waves, and chemical fluxes into a kind of physiology. At the center lies metal, hot and convecting, an inner world that behaves like a heart. Pure iron crystallizes as it cools, forming a solid inner core that grows imperceptibly outward into a liquid mantle of nickel and iron. The outer core is a boiling, electrically conductive ocean. As patches of metal cool and sink while others rise, they braid magnetic fields around them. Those fields, invisible and immense, shelter the planet from torrents of charged particles, shaping the chemistry of the upper atmosphere and, by extension, the habitability of the surface. The dynamo does not pump blood, but its motion is no less fundamental. It sustains a protective cocoon, modulates charged radiation, and occasionally flips polarity in reversals that are like arrhythmias written across millions of years. One can make the metaphor operational by imagining a descent. The surface is familiar, the thin skin of continents and oceans where weather and life meet. Descend through the crust and pressure thickens, temperatures climb, and the soundscape of rock changes. Seismic waves, both the quick, brittle P waves and the slow, sweeping swaves, are the diagnostic signals that reveal internal structures. Geophysicists place seismometers across the world and, when earthquakes or human-made pulses occur, read those tremors like a stethoscope on a chest. From those oscillations, an image emerges, layered regions that bend and refract sound, subtle slow motions that suggest convection, pockets of different composition that tell a history of melting and mixing. The inner core's slow freezing and the outer core's boiling currents are not dramatic to the human senses, but their cumulative force structures everything above. Surrounding that metallic heart is a mantle the size of continents, a vast muscular layer whose slow convection drives the motion of rigid plates above. Mantle plumes rise like muscular contractions, delivering thermal anomalies that thin the lithosphere and feed volcanic fountains. Subduction zones, where one plate collapses beneath another, act like digestive conduits, recycling oceanic crust back into the mantle. In these zones, slabs sink and release fluids that lower melting points, generating melts that rise to make island arcs and continental margins. The mantle's flow patterns are the slow gestures of an immense organism, upwelling and downwelling, bending and folding, a choreography that reshapes the outer shell through tens of millions of years. The outer shell of the planet, the lithosphere and the crust, behaves like skin and skeleton at once. Continents are buoyant rafts, ancient, thick cratons that float higher because of their low density, thinner oceanic crust that forms at mid-ocean ridges and vanishes at trenches. Mountain ranges are the scars and sutures produced when those rafts collide. A mountain chain is not a single object, but a history rendered in stone, folded strata, thrust faults, roots of thickened crust that extend deep into the mantle. Erosion sculpts those summits down. Rivers carve their way through uplifted plateaus and take the product of that wearing into the sea. Mountains, in this sense, are both skeleton and workshop. They lift fresh minerals into the weathering zone, provide gradients for rivers and glaciers, and create the microclimates that allow complex ecosystems to flourish. Their rise and decay are long-term gestures of repair and renewal. Rivers and oceans are the planet's vascular system, channels that shuttle heat, solutes, sediments, and life from place to place. A river is a concentrated energy pathway. Gravitational potential becomes kinetic flow, which grinds rock, chews soil, transports particles, sorts them by size, and deposits them when energy wanes. Deltas are the terminal sinks where fluvial lifeblood slows and spreads. Ocean currents, wind-driven surface streams, and the deep thermohaline conveyor redistribute heat across latitudes. A warm Gulf Stream warms coasts otherwise destined for colder climates. An interruption of the conveyor is, in climatic terms, a circulatory failure. The ocean's ability to store heat, dissolve gases like carbon dioxide, and host biological pumps that fix and transfer carbon ties it intimately to the planet's long-term regulation. In short, where heat goes, life often follows. And where life thrives, the chemical composition of the water and air changes. The atmosphere and cryosphere are the breath. Winds are exhales, storms are gusts. The slow advance and retreat of ice sheets are breaths across ages. Glaciers grind and polish landscapes, carrying enormous loads of gravel and boulders down valleys. Ice sheets, when they advance, lock up volume and lower sea levels. When they retreat, seas reclaim drowned shells and reshape coastlines. These massive oscillations in water storage alter circulation patterns and climate feedbacks, sometimes gently over tens of thousands of years, sometimes abruptly in a few centuries. When feedbacks amplify, such as the albedo effect leading to runaway cooling or methane release hastening warming, the planet can enter states that feel like febrile illness. In geological terms, those are episodes of rapid, large-scale reorganization. Underpinning all of this is a set of cycles that function like metabolism. The carbon cycle is the most prominent. Carbon moves from atmosphere to biosphere to sediments to mantle and back. Weathering of rocks draws down carbon dioxide, locking it into carbonates that eventually form limestone. Subduction drags those carbon-bearing rocks into the mantle where volcanism can return carbon to the atmosphere. Life amplifies and modulates these fluxes. The early rise of photosynthesis gradually changed atmospheric chemistry, allowing oxygen to accumulate and creating new redox boundaries on the crust. These are not random chemical transactions. They are systemic flows that maintain, restrain, and sometimes destabilize climate. Nutrients like phosphorus and nitrogen circulate in their own loops, limiting or fueling productivity and shaping where life can multiply. Memory is written in sediments, crystals, and isotopes. Layers of sediment stacked like a palimpsest, recording floods, droughts, volcanic eruptions, and biological bloom and bust cycles. Zircon crystals carry isotopic traces of the water-rock interactions that happened billions of years ago. Banded iron formations tell a story of the oxygenation of the oceans. Ash layers timestamp volcanic episodes. Yet the memory is partial and edited. Subduction eats oceanic crust. Metamorphism overwrites chemical signatures. Erosion buries older horizons beneath blankets of younger deposits. The planet remembers selectively. Some archived, cratonic shields, deep mantle plumes, robust mineral grains retain ancient information while others are erased by the constant churn. The paradox is striking. The same processes that make Earth habitable, plate tectonics and mantle convection, also erase the footprint of their own past. Seismicity and volcanism are the planet's alarms and celebrations. Earthquakes can be sudden, violent shivers when accumulated strain releases along faults, the brittle crust's way of adjusting to slower, persistent mantle movements. Volcanoes are portals where deep-seated material meets the surface, sometimes as gentle, sustained plumes that build islands and enrich soils, sometimes as cataclysms that spew aerosols and lava across continents. Large igneous provinces, those prodigious flood basalts, are episodes of planetary-scale outgassing that may coincide with mass extinctions. In the metaphor, volcanoes are febrile flares, earthquakes are coughs or shudders. Their patterns and frequencies are diagnostics that, when read over time, show a body that is both responsive and dynamic. If the planet possesses anything like a nervous system, it is diffuse and functional rather than centralized. The geomagnetic field offers a kind of global, nervous scaffold, guiding charged particle flows and shaping where ionization occurs in the upper atmosphere. Electrical currents in the ionosphere and magnetosphere braid with solar wind impulses, producing auroras that are vivid expressions of these interactions. Chemical gradients, redox potentials at hydrothermal vents, salinity contrasts at estuaries, are localized signaling environments that host chemical reactions and, later in Earth's history, biological metabolism. Microbial mats and biofilms, in turn, can influence the chemistry of their immediate surroundings, amplifying signals and altering substrate properties over time. Information in this sense is embodied as spatial and temporal patterns of chemistry, mineralogy, and energy flow. Reading these patterns requires instruments and frameworks that can translate geology into narrative. Seismographs map the interior, magnetometers probe the field, satellites measure gravitational anomalies and topographic change. Geochemical analyses decompose rocks into histories. But whatever the method, the essential challenge remains to distinguish between background complexity, the noise of a billion years of interacting processes, and coherent, repeated patterns that might, speculatively, be interpreted as signs of organized, sustained responses. The problem is epistemic and aesthetic. It forces humility. A planetary response might not be a directed intent in any human sense. It could instead be a robust, emergent regularity produced by coupled feedback loops, the geological equivalent of homeostasis. There is an emotional cadence to this reflection. The image of molten metal beating like a heart carries both comfort and terror. Comfort, because the dynamo protects a biosphere that otherwise might have been stripped of its atmosphere and sterilized by solar wind. Terror, because the same internal processes can, at times, produce conditions inimical to life. The planet's scales of time compress and expand the human sense of consequence. Anthropogenic emissions, concentrated in mere centuries, appear like a sudden, sharp spike on a deep-time graph, a fever whose trajectory is uncertain. Tipping points in the climate system, thresholds in ocean circulation, collapse of ice sheets, permafrost thaw, releasing greenhouse gases are the kinds of non-linear transitions that a physiological metaphor captures. Well, once a regulatory mechanism is overwhelmed, recovery can be slow and transformative. Yet the metaphor should not be fetishized. There is no homunculus deciding. There is no animal-like consciousness sitting in the core. Instead, the value of the metaphor is heuristic. It provides a way to think about integration, pattern, and feedback on planetary scales. It reframes stewardship as not only ethical obligation, but as participation in a set of processes that have their own momentum and inertia. To alter the composition of the atmosphere is to change a circulating fluid. To erode soils or dam rivers is to reroute veins. The planetary body responds, but on its own terms and timescales. Finally, there is the question of signal and silence. The Earth speaks in many registers, in the steady hum of mid-ocean ridges creating new crust, in the catastrophic staccato of impacts and flood basalts, in the steady chemical whisper of weathering and carbon burial. To listen is to span frequencies from seismic seconds to magnetic reversals measured in hundreds of thousands of years. The tools of listening are records and sensors, but perhaps more profoundly, they are modes of imagination that can translate gradients into stories, stories of stability and collapse, of slow repair and sudden remaking. Whether that translation yields the claim that Earth is a living thing depends on definitions. But even absent a literal sentience, seeing the planet as a body encourages an ethic of attention, to read scars without flinching, to watch pulses without panic, to act with the knowledge that interventions ripple through a complex physiology with effects that will play out long after any single life has ended. In the next long chapter of this speculative documentary, the focus will shift toward the interfaces where geology and chemistry conspire to create habitats for life, the margins where hot, mineral-rich fluids meet cold seawater, where tidal pools concentrate organics, and where sediments bury the experiments of molecules into more stable record. For now, the listener is left with the image of the planet's internal structure as a layered, interacting body, a molten core that beats and shields, a convecting mantle that moves and reshapes, a fractured crust that bears scars and supports life, and a circulatory system of water and atmosphere that distributes energy and matter. Together, these systems produce rhythms and pulses, memories and erasures, a long, slow symphony that invites both scientific scrutiny and moral reflection. What if the air above the world could be heard, not in the crackle of a radio or the hiss of a vent, but as a slow, planetary breath? An inhale that draws the dark scent of cold into itself, and an exhale that returns warmth and change. That image is not mere metaphor, it is a way of listening. The atmosphere moves, exchanges, and balances on scales that confound ordinary intuition. It takes some sounds to understand the music, the thin, seasonal rasp of leaves in autumn, the muffled, stately gulp of ice sheets growing by millennia, the sudden wheeze of a methane pulse from melting permafrost. All of these are notes in a composition that has been playing across deep time, a rhythm made of gas, water, dust, and life. Viewed as lungs, the atmosphere does what lungs do, it mediates exchanges. Photosynthesis and respiration are the repeated contractions and relaxations of that exchange, the great metabolic duet. During daylight, green surfaces, microbial mats, and oceanic phytoplankton draw carbon dioxide down into organic matter and release oxygen. At night, amid decay, respiration pushes CO2 back into the air. This diurnal cycling is a small, loud beat. Above that beat, seasons rise and fall as deep inhalations and exhalations, driven by the tilt of the planet and its elliptical path around the sun. Trees in high latitudes swell with chlorophyll come spring, drawing down carbon in a collective inhalation. In autumn, they surrender, shedding leaves and exhaling nutrients back into the soil and air. In the oceans, phytoplankton blooms are like transient bellows. When nutrients and light align, they breathe down billions of tons of CO2 before sinking as particulate organic carbon, sequestering a fraction of that breath to the deep. But the planetary breath is not neat or steady. It is punctuated by the slow, enormous cycles that geology writes into the climate record, glacial and interglacial cycles. The grandest of the planet's respiratory motions in the late Quaternary are breaths that expand and contract over tens to hundreds of thousands of years. Each glacial maximum, with ice sheets grinding across continents and seas locked in cold, is a deep inhalation. Oceans sequester particular qualities of heat. Sea level drops, the atmosphere changes its composition, and ecosystems retreat to refugia. The ice acts like a muffling diaphragm, altering albedo and atmospheric circulation. Each interglacial, when ice retreats and seas rise, is an exhalation of warmth, a reconfiguration of biomes and atmospheric chemistry. The driver behind the timing of these breaths is subtle and celestial. Small shifts in the tilt and shape of the planet's orbit, the Milankovitch cycles of obliquity, eccentricity, and precession nudge where and how solar energy is distributed. But those nudges only set the tempo. Feedbacks amplify or mute the response. Feedbacks are the lungs' reflexes. Ice albedo feedback, for instance, is brutally simple. More ice reflects more sunlight. Inviting further cooling, less ice exposes darker seas and land, absorbing more heat. Carbon feedbacks are more complex. As oceans cool, they can absorb more CO2. As they warm, they release it. The biological pump in the ocean, dependent on nutrient delivery and stratification, can draw down carbon into sediments for geologic timescales, or it can ease, allowing more CO2 to remain in the air. Terrestrial systems have their own reflexes. Growing forests pull down carbon and can stabilize climate locally, but drought, stress, and fire can turn them from sinks into sources in a single season. These are not mechanistic, predictable responses in the simple sense. They are dynamic, contingent, and often non-linear. They are the planet's way of maintaining balance and, at times, reorganizing itself. To read these rhythms, scientists pierce the air with ice cores and sediment columns. Tiny bubbles trapped in Antarctic ice are time capsules of ancient atmospheres. They testify to the composition of past breaths. Isotopic fingerprints in those bubbles and in marine sediments reveal temperature swings, greenhouse gas concentrations, and even the seasons of ancient storms. From those records emerges a portrait, glacial inboards that last tens of thousands of years, punctuated by rapid warming events where temperature and greenhouse gas concentrations spike in mere centuries or decades. In some moments, the atmosphere has acted with gentle rhythm, and in others, it has convulsed. The planet's breathing has not always been harmonious. Life has been both a driver and an instrument of that breath. The great oxidation event, 3 billion years ago, was the planet's first monumental exhale of oxygen. Microbial photosynthesis, first shallow and sporadic, eventually shifted the balance of atmospheric chemistry so profoundly that the world's red rocks transformed into banded iron formations and then into an atmosphere hospitable to aerobic life. Later, the proliferation of forests and the evolution of soil significantly altered the carbon balance, changing how the planet inhaled and exhaled over geological timescales. Each evolutionary innovation, the first multicellular organisms, the advent of land plants, the spread of C4 grasses added complexity to the respiratory system, creating new sinks, sources, and pathways for gases to move. The ocean is a second set of lungs, one that breathes at different rates in different places. Surface waters exchange gases quickly with the atmosphere. Deep waters, once isolated, can store heat and carbon for centuries to millennia. Upwelling zones vent stored carbon back to the surface. Downwelling regions take dissolved organic carbon and bury it in the abyss. When the thermohaline circulation, the planet's oceanic conveyor belt, shifts, it changes where and how the ocean breathes. A slowdown in that circulation is like constricting a lung. Heat and nutrients pool differently, altering ecosystems and atmospheric composition. The drama of past climate change often hinges on these oceanic adjustments. Clouds and aerosols are the alveoli, small but crucial spaces where gases and heat are exchanged. High clouds trap heat, acting like greenhouse blankets. Low clouds reflect sunlight, cooling the planet. Aerosols, from volcanic dust to sea salt and industrial soot, seed clouds and scatter sunlight. Volcanic eruptions can inject particles into the stratosphere that reflect sunlight for years, a temporary inhalation of coolness. Conversely, large releases of greenhouse gases from volcanic provinces or from thawing geological reservoirs can provoke potent exhalations of heat. In every case, the interplay of particles, droplets, and gaseous chemistry dictates how much of the sun's energy is kept near the surface. The cryosphere contributes its own slow, implacable respirations. Ice sheets grow where snow accumulates faster than it melts, compressing into storied layers that archive past climates. When they expand, they sequester water and lower sea levels, rearranging coastlines and imposing new constraints on ecosystems. Rapid melt, an exhalation in geological shorthand, floods shells, redraws habitats, and reconfigures ocean circulation. Meltwater pulses, episodic and profound, have recast shorelines and triggered abrupt climate shifts in the past. Permafrost, frozen for tens of thousands of years, stores organic matter waiting like arrested breath. Its thaw is more than a local event. It is a release valve that can inject greenhouse gases, CO2 and methane, into the atmosphere with the power to accelerate warming. There is a moral texture to these physiological metaphors. The planet's breath has always been modulated by slow, emergent processes, but in the last few centuries an unprecedented human inhalation and exhalation has begun, the burning of fossilized carbon accumulated over geologic ages. This is ancient breath exhaled suddenly into a modern world. The speed and magnitude of this release are out of sync with the long reflexes of the Earth system. Soil, ocean, and vegetation sinks absorb some fraction, but the residual nearly straightens the long-term curve of atmospheric CO2 upward, a spike on a graph that has seldom seen such steepness in millions of years. The result is an acceleration of warming, shifts in precipitation patterns, an increase in extreme weather, and the carving of potential tipping points. Tipping points are the arrhythmias to fear. When a regulatory mechanism is overwhelmed, the system can flip into a new state. An Amazon forest, stressed by drought and deforestation, might transition from carbon sink to savanna-like emitter, altering regional rainfall and further reducing forest resilience. The Greenland and West Antarctic ice sheets each possess thresholds beyond which retreat may become self-sustaining. Once certain areas begin to melt and collapse, the geometric feedbacks of ice dynamics and ocean warming can make reversal difficult on human timescales. Methane hydrates locked in continental shelves may destabilize with warming seas, releasing potent greenhouse gases in pulses that further accelerate change. These are not the steady, harmonic breaths of a healthy system. They are the sobs and gasps of a body pushed toward a new equilibrium. Yet the breath metaphor is not a tale of doom devoid of agency. It is also a record of remarkable resilience and repair. The Earth has repeatedly rebounded from episodes of profound change. After mass extinctions, new ecologies have arisen. After glaciations, life has repopulated and re-engineered landscapes. The carbon cycle, when given time, can draw down elevated CO2 through weathering, sedimentation, and biological sequestration. The time scale, however, matters. The The slow gears of carbonic burial and tectonic processing operate over tens of thousands to millions of years. If the human influence aims to be responsible, it must reckon with the mismatch of rates. Some things can be corrected within decades with policy and technology. Others require patience measured in generations. The listener of this narrative is left with a set of visceral images. Picture the planet inhaling, ice creeping like a pale tide over continents, atmospheric CO2 retreating to the oceans and the depths, forests shrinking into refugia, sea levels collapsing, and dust turning the wind to powder. Picture it exhaling, ice melting, sea levels rising, coastlines reminding the living of past shapes, forests expanding, ocean upwelling, releasing long-held carbon. Each transition was not smooth, but punctuated by rapid shifts, warmings that surprise and reorganize life. All of these annotations are preserved in proxies, the oxygen isotopic ratios in foraminifera, the delicate layering of annual ice bands, pollen signatures that map the advance and retreat of plant species. They are court records of the planet's respiratory history. To frame the atmosphere as lung is to reframe responsibility. It renders visible the ways in which incremental choices, a city's transportation system, a nation's energy policy, the fate of a single forest, resonate with planetary physiology. A wetland conserved today is not merely a habitat saved, it is a functioning alveolus in the global exchange of water and carbon. Restoring soils, allowing forests to regrow, protecting peatlands, these are acts of respiratory therapy at planetary scale. Conversely, rupturing permafrost or clear-cutting ancient forests is like opening a wound in the lungs and letting air foul the blood. There is also a deep humility knitted into the reflection. Standing beneath the blue vault, people feel small because the breath they witness is an echo of processes too long and vast for single lifetimes. This humility can be paralyzing if it breeds helplessness. It can also be energizing if it becomes a summons to stewardship. Listening matters. The tools to measure the breath exist and are growing more sophisticated. Satellites watch the planet's exhalations and carbon fluxes. Ocean floats map thermal shifts. Ice cores offer backward glances. But statistics and instruments are only part of the ritual. The other part is imagination, the ability to feel the long pulls and pushes of the earth, to see human activity as an overlay on a machinic, breathing whole. The final, disquieting image is a graph with a steep spike at the present. It is a visual jolt, a century of change writ sharp against a backdrop of glacial cycles and steadier fluctuations. What follows that spike depends on choices. Whether emissions plateau and decline, whether nature-based solutions are scaled and sustained, whether technologies emerge to remove carbon from the air at meaningful rates, and whether global governance aligns incentives toward long-term stewardship. The planet will respond, as it always does, according to the physics and chemistry that govern its lungs. It may adapt, reconfigure, and eventually find a new rhythm. The question for those listening now is whether that new rhythm will retain the conditions that gave rise to complex human societies, or whether it will settle into a cadence less hospitable. So the atmosphere breathes in cycles and surges and quiet seasonal tastes. It inhales carbon and exhales oxygen. It stores memory in ice and rock, and it responds to the slow governance of geological forces and the sudden impulses of life. To attend to that breathing is to reckon with scales that humble daily life, but also to recognize the levers that exist within human reach. The invitation is not merely analytical, it is ethical. Listen, not as a passive witness, but as a steward. The lungs of the world are not distant organs, but active, participatory systems. And the choices made within one generation will echo through many more breaths than any single human life can count. What does it mean to say that a planet's flesh was first woven not from bone or bark, but from single-celled craftsmen? What image holds when the earliest life is not a roaring megafauna, but a microscopic bureaucracy of chemistries and membranes? Billions of tiny factories working, dying, and altering their world in a slow, almost invisible choreography. That question frames this chapter. The first living forms as the cells of a planetary body, the small makers whose collective labors would sculpt atmospheres, sediments, and climates across millions of years. For a long span of deep time, Earth's surface was less a stage and more a skin, an interface where chemistry met energy, and where simple compartments learned to maintain difference. The earliest inhabitants were not thinkers or engineers, but molecules that found rhythm in repetition. Lipid bubbles conjoined with catalytic minerals, proto-membranes, trapped reactions, and, eventually, polymers that could copy parts of themselves became enclosed in boundaries. These were the first experiments in being a discrete system amid a permissive soup. Their actions were not choices but lawful tendencies: divide when resources permitted, coat surfaces when nutrients concentrated there, produce byproducts as waste, and in doing so alter the immediate environment. Imagine a tidal flat long before cities, where a thin veneer of water warmed under a watchful, harsher sun. In the shallows, mineral grains offered footholds. Tiny mats of slimes, biofilms, grew as invisible carpets of cells enmeshed in sticky polymers. They trapped sediments, precipitated minerals, and built layer upon layer. Day after day, season after season, these films thickened and lithified. Over geological spans, such layered structures became stromatolites, domed, columnar, lithified mounds that stand as fossil testimonials. The visual of a stromatolite is slow and patient, a living tessellation accreting calcium carbonate millimeter by millimeter, its form recording the rhythm of microbial growth, the chemistry of seawater, and the light of an ancient sun. These microbial communities were not incidental. Each metabolic pathway that evolved was both a micro-level solution and a planetary-level act. Photosynthesis, when it emerged in some bacterial lineages, introduced a profound asymmetry. In exchange for harvesting sunlight and converting carbon dioxide into organic carbon, oxygen was released as a byproduct. That oxygen, tiny molecule by tiny molecule, began to accumulate in pockets and basins. For millions of years it was a local irritant, toxic to many existing metabolisms that had adapted to anoxic conditions. But over the sweep of deep time, this slow production of oxygen, perhaps episodic, perhaps patchy, etched its mark onto iron-rich seas, leading to the precipitation of banded iron formations when dissolved iron met oxygen and fell out as rust. Those iron layers are not decoration. They are the ledger of a long biochemical negotiation between living mats and the oceans they lived in. Not all early photosynthesis went the same route. Anoxygenic photosynthesis, using sulfur or other electron donors instead of water, continued in dimmer, deeper margins, in sulfate-rich lagoons and beneath early mats. Chemoeutrophs, those organisms that gain energy from chemical gradients rather than sunlight, colonized the dark sea floor and the fissures of hydrothermal vents. At the bases of black smokers, where mineral-rich fluids met cold seawater, rich microcosms thrived on chemical energy alone. There was no sunlit choreography here. The energy came from Earth's interior. Those microbial communities catalyzed the conversion of hydrogen sulfide and iron into biomass and mineral precipitates, building chimneys of sulfide and laying down mineral tapestries that would later be read as habitable signatures. Every metabolic innovation nudged the planetary engine. Nitrogen fixation allowed life to break apart inert atmospheric N2 and fold usable nitrogen into biomolecules, enhancing productivity where fixed nitrogen had been limiting. Sulfate reduction released hydrogen sulfide into waters, altering local chemistry and sediment diagenesis. Methanogenesis. Primitive archaea producing methane pumped a potent greenhouse gas into the air, insulating the world in eras when the sun's output was weaker. In short, the earliest life did not merely inhabit the world, it engineered the chemical conditions that would influence climate and habitability. Each species was a tiny worker in a global factory, each metabolic pathway a factory line altering the fluxes of atoms and heat. The metaphor of cells as tissue begins to sharpen when one observes scale. A single bacterial colony is negligible. Within an ecosystem of mats across a continental shelf, their combined activity becomes a tide. Photosynthetic mats change the reflectivity, the albedo of shallow shelves. By drawing down CO2 and altering carbonate chemistry, they influenced the buffering capacity of the ocean. When mats calcified, they sequestered carbon into sedimentary carbonates. When microbes respired, they returned carbon to the atmosphere and drove local hypoxia. Across the planet, myriad microscopic acts stitched into patterns, carbon sequestration here, methane release there, iron oxidized in one basin and preserved in another. From the vantage of deep time, the collective life of microbes had the coherence of tissue carrying out metabolic tasks for an organism that had not yet learned to call itself alive. This is not to ascribe intentionality, but to note integration. Ecosystems of microbes created feedbacks that could be stabilizing or transformative. The Great Oxidation Event is the canonical example, an epoch when oxygen's presence changed from being a local curiosity to a global agent. For perhaps more than 1 billion years, oxygen produced by cyanobacteria was scavenged by reduced minerals and dissolved iron. But as sinks saturated and oxygen production continued, atmospheric oxygen rose markedly. That shift reconfigured redox chemistry worldwide. Iron ceased to accumulate in solution. Organic molecules faced oxidative degradation more readily, and new ecological niches opened for metabolisms that could tolerate or exploit oxygen. The planet's atmosphere, once a simple enveloping mixture, became a reactive partner in life's unfolding. Stability and change walked hand in hand. Microbial mats could persist for tens of millions of years across shallow shelves, tetrametalites growing slowly as storms and sea level schist deposited and eroded. Yet they were also vulnerable. The later arrival of grazing organisms, simple multicellular forms that could consume mats, would disrupt some of these long-standing communities. But those disruptions too generated novel niches. The microbial world, always inventive within its constraints, generated symbiosis and associations that multiplied possible forms of life. One of the most consequential of these associations was endosymbiosis, the merging of distinct prokaryotic cells to form a new, more complex cellular architecture. In time, these unions gave rise to eukaryotic cells with internal organelles, a leap that would set the stage for multicellular complexity. The smallness of the actors did not dictate the smallness of the consequences. The fossil and chemical traces of these early actors are often subtle and contentious. Rocks record their presence in microfossils, in isotopic ratios biased by life's preferential use of lighter isotopes, in molecular fossils, organic remnants of cholesterols or hopanes that betray an ancient biology. A teaspoon of ancient sediment can hold fingerprints of metabolic routines, carbon isotopes shifted by photosynthetic fractionation, sulfur isotopes indicating microbial sulfur cycling, biomarkers that name distant lineages. Each proxy is a fragment of a broader story. Together they show that for well over 1 billion years, life on Earth wore the guise of microbial swarms, their slow, patient labors gradually altering the planet's air, sea, and sediments. There is an emotional architecture to this realization that modern listeners often feel a mixture of awe and vertigo. Awe, because the idea that invisible organisms could so comprehensively reshape global chemistry humbles technological arrogance. Vertigo, because it reveals human time as a brief flare against a background of billions of years during which the tiny makers composed the bulk of habitability. Where humans often measure significance by scale or visibility, the microbial era insists that persistence and integration can be as consequential as size. The planet's body was stitched together by hands invisible to naked sight, operating with patient economy. Speculation enters at the margins but remains disciplined. Could these microbial communities, dispersed and networked across shells and vent fields, have constituted a form of distributed information processing? They certainly process signals, gradients of light. Chemical potential and redox state produce patterns of gene expression and community composition. Biofilms coordinated activity through quorum-sensing molecules, aligning metabolism when local conditions warranted. In a metaphorical sense, these processes are not unlike tissue-level signaling in higher organisms. Local changes propagate, neighbors respond, and the ensemble shifts state. It is tempting and instructive to imagine the planet's early biosphere as a living fabric interlacing the sterile frame of rock and water. Each species was like a cell in a mucous membrane, simultaneously autonomous and contributory to larger functions. This view reframes stewardship and curiosity. If the organism that humans inhabit was first assembled by bacteria and archaea, then much of what is essential to life on Earth is microbial soil fertility, oxygen balance, carbon sequestration, nitrogen availability. Human actions that disrupt microbial ecologies through pollution, land conversion, antibiotic overuse, or ocean acidification are not merely local insults, they are alterations of the tissue whose functions sustain global habitability. Conversely, restoring microbial systems, rehabilitating soils with microbiome-conscious practices, protecting coastal wetlands, allowing seagrass meadows to recover, are reparative acts at a foundational, functional level. There is also a narrative of loss and memory. The geological processes that are necessary for a habitable planet, plate tectonics, weathering, sediment burial also erase much of the detailed record of early microbial life. Subduction consumes oceanic crust where microbial deposits once lay. Metamorphism transforms delicate molecular fossils beyond recognition. What remains is selective and often fragmentary. Yet within that fragmentary archive lie signals of strategy, metabolic redundancies, niche partitioning, and long-term feedbacks that shaped atmospheric composition. These are the kinds of clues that a speculative documentary mind leans on, the meditated inference that microscopic actors, acting at planetary scales over millions of years, compose an integrated physiology of sorts. This chapter, then, must balance close-up wonder with broad humility. It can linger on a single microcosm, an ancient tide pool where ultraviolet light cracked molecules by day and chemistry, reassembled them by night, expanding that scene into an epoch. It can slow down to describe the sticky texture of a microbial mat, how it traps silt like mucus trapping dust, how colonies migrate centimeter by centimeter across a shelf, secreting mineral-inducing polymers that cement their work into stone. It can zoom out to track the cumulative effect of countless such processes, the oxygenation of seas, the sequestration of carbon in limestone, the shift in greenhouse forcing via methane fluctuations. That movement between scales, microscope to planetary ledger, is the emotional engine of the story. And therein lies a moral whisper. Large, visible changes often rest on the quiet competence of microscopic actors. To imagine oneself as part of a planetary body whose first tissues were microbial is to inherit a debt of stewardship toward those foundational systems. The planet's health was built on the patient, iterative work of bacteria and algae that balanced chemistry and climate. The present, a time of conspicuous human alteration, is unique in the speed and scope of intervention. The question becomes not whether microbes once made the world habitable. They did, but whether humanity will recognize the primacy of these small makers and act in ways that repair rather than rupture the tissue that supports all larger life. In the slow litany of deep time, microbes are the faithful laborers, silent but indispensable. They are the first cells of a planetary body whose later flares of complexity and consciousness will be possible only because the invisible chores of metabolism had been completed at scale. To watch their fossil traces is to read marginalia in a vast, hand-drawn manuscript of life. Marginalia, that rewrites central chapters when properly understood. This realization both humbles and grounds. Humbling because human histories are flashes on a long page, grounding because it reconnects human futures to a processual substrate that is often overlooked. The tissue of Earth was, and remains in many ways, microbial. Recognizing that is the first step toward listening to a planet whose earliest heartbeat began in the slow, patient rhythm of single-celled life. What if the sensation of beauty were not merely a private reaction in a human skull, but a way of knowing the planet itself? What if the momentary hush that falls when the eye traces a silver coast or a green canopy from above were a kind of listening, an aesthetic opening through which the slow music of the earth becomes legible? That image is the hinge of this chapter. The globe as a round, radiant living thing, its illuminated curvature suggesting not a pale or inert rock, but a full-bodied organism breathing light and color. From that vantage, the intimacy that follows is not metaphor only, it is a felt fact. Humans look down at continents and seas and experience a strange closeness, as if they were neurotransmitters in a vast brain, small sparks across a thinking surface. Seen at once in an atlas and in a time-lapse, the planet composes itself into rhythms, dawns that flare across continents, nights punctuated by city lights that glimmer like neuronal clusters, cloud systems that swirl and untwist as if mood were weather. The aesthetic impression of the Earth from orbit is immediate and strangely humane. It registers as a body, round, warm where suns catch oceans, textured where forests wrinkle into mountains. This visual grammar invites a certain intimacy. Observers, collective, transhistoric, report the same psychic contraction, a feeling of belonging and humility, then an aftershock of vertigo. The sight compresses scale. Mountains lose their towered dominion, oceans shrink to color fields, the borders that once divided. Peoples dissolve into lines on an illuminated globe. Perspective flips the familiar. Where once the ground was private and immediate, now it is part of a whole. That psychological flip is worth holding open. The feeling of being inside. A living sphere encourages a peculiar empathy, an aesthetic empathy that operates like listening. It is not passive. It shifts attention to rhythms rather than objects, to processes rather than monuments. Daylight becomes a slow planetary brushstroke. Seasons read like movements in a symphony. The visual poetry of forests greening and browning, of rivers widening and narrowing, of monsoons sweeping continents, becomes a choreography of time. Time-lapse sequences reveal that what looks static is a ceaseless performance. A hill slope heaves across millennia, a delta fans outward centimeter by centimeter, plankton blooms flash across seas, and then fade like a musical phrase. Each movement sings to a scale of patience that overwhelms ordinary perception. The aesthetic response is thus double-edged. It delights in pattern and scale, and it presses the viewer into a moral register. There is a neurological image that maps neatly onto the aesthetic. City lights at night, mapped at global scale, look uncannily like networks of activity, clusters in some regions, long filaments elsewhere. They resemble neural maps of a brain on the move, nodes connected by filaments of travel and trade, bursts of light standing in for spikes of thought. From space, those lights are a choreography of human metabolism, energy spent on comfort, illumination, data, and transit. The patterning of those lights over time, seasonal dimming and brightening, sudden blackouts during storms, gradual expansion into new suburbs, reads like a brain engaged in work and play. It is tempting and tempting alone to translate this into a claim about planetary cognition. The lights are not thought. They are evidence of a distributed technological nervousness that both responds to and modifies planetary rhythms. Aesthetics, in this framing, becomes a means of ethical calibration. Beauty provokes attachment. Attachment can become responsibility. The glow of the planet as a whole has pressed human cultures to create myths and rituals that attempt to harmonize with these grander rhythms. Around the world, festivals still align with solstices and equinoxes. Rivers are worshipped and mourned. Seasonal songs and harvest rites bind communities to cyclical change. These cultural techniques are, in a sense, low-tech attempts to synchronize human tempo to planetary tempo. They are aesthetic practices with practical outcomes. They regulate fire and harvest, conserve soil and water in ways that, over centuries, alter the distribution of life across landscapes. In that light, beauty and care are contiguous. Aesthetic resonance has been a vector for long-term stewardship. But closeness harbors ambivalence. The aesthetic allure of a shining, forgiving planet also masks the fact that human beings are not only sensors but agents. When neurons pass signals that are ephemeral and communicative, Schumann nodes output materials and heat and waste in concentrations unprecedented in Earth's recent history. The same maps that seduce with beauty also show scars, deforested patches that puncture green mosaics, coastlines altered by rising seas, spectra that show warming oceans. The emotional response to seeing the glow often slides from wonder to guilt or anxiety. That transition from I belong to, I have broken, is an aesthetic and moral jolt. Feeling small within a living whole does not automatically produce good behavior. It can produce despair, paralyzing the will, or it can ignite a kind of attentive care. The aesthetic rhythm of the planet is tightly bound to temporal rhythm. Day becomes night in a single rotation. Seasons came and go as the tilt of the axis determines sun angles. Tides choreograph. Shorelines, monsoons build and collapse annually. Each of these cycles offers its own aesthetic. The copper hush of an autumnal canopy, the luminous green surge of spring, the satin swells of tidal flats, the slow glacial whiteness spreading and retreating over millennia. The human perceptual apparatus can attune to many of these rhythms, the daily and seasonal ones, but misses most of the rest. Without instruments, yet even the ephemeral rhythms carry deep emotional freight. The annual emergence of migratory flocks or the synchronous flowering of certain plants can trigger communal celebrations. Those episodes are aesthetic puncta that stitch together memory and place, and they function as cultural heartbeats, repeated, expected, cherished. Their loss is therefore not only ecological but cultural, an erasure of tempo that collapses meaning. This is where the aesthetic diagnosis becomes political. Rhythm and pattern are not neutral. They embody dependencies, the nesting of life cycles on climate regimes, the reliance of agriculture on predictable rains, the timing of spawning on temperature curves. Disrupt those rhythms abruptly, and the aesthetic cohesion fractures into dissonance. A coastline that once hosted seasonal fisheries becomes barren. A mountain meadow that flashed in color each spring becomes a sere slope. The planet's beauty is partly a condition of balance, and aesthetic disruption is an early symptom of physiological shock. There is a further, subtler register to consider: aesthetic rhythm as a means of communication across scales. Time-lapse images, satellite mosaics, and planetary sonifications are not merely tools for scientists. They are translations of non-human processes into human-friendly modes. They make visible the invisible surge of phytoplankton that colors oceans, the chlorophyll pulse that sweeps the Amazon. the nocturnal hum of urbanization. In converting data into color and motion, human storytellers craft an aesthetic vocabulary that can prompt moral imagination. A well-timed sequence showing the spring green bursting across a hemisphere can make abstract carbon budgets feel immediate. Art becomes translation. It carries deep time processes into sensory forms the human mind can respond to. That is a power that science and art share, the power to re-embed large-scale dynamics into felt experience. Yet this translation is not neutral. The aesthetic choices, framing, color palette, tempo, steer interpretation. A slow dissolve of ice in a documentary montage invites sorrow. A sped-up staccato montage of wildfires provokes alarm. The ethics of aesthetics matter because the emotions they produce condition responses. The planetary aesthetic can be harnessed to cultivate a steady, patient attention or to incite panic and short-term fixes. The documentary voice must therefore keep pace with the planet's own temporal modes. An image may be beautiful, but the emotional architecture around it must be calibrated to the long haul. There is also a speculative move worth entertaining here. If the Earth were capable of fashioning aesthetics, if it had a preference, an orientation, what might it favor? The imagination slides into metaphor. Constrained by earlier reflections about planetary senses, perhaps it would favor gradients and heterogeneity, the textured complexity that ensures resilience. Varied coasts, interlaced habitats, diverse soil microbiomes. These are aesthetic configurations that also confer function. Symmetry and uniformity may read as beauty to some human tastes, but for a living planet, resilience often correlates with diversity and unevenness. The planet's taste might therefore be a palette of variation, a preference for mosaics that harbor many possible futures. Human activity that smooths variety into homogeneity, monocultures, paved surfaces, leveled coastlines, runs counter to that aesthetic and functional preference. This speculative stance reawakens an ethical dimension. Aesthetics can guide repair. When people learn to find beauty in complex, functionally rich landscapes, wetlands, mixed forests, traditional polycultures, they are more likely to preserve them. Conversely, when the only beauty commodified is the manicured and the uniform, the planet's more subtle, robust configurations are threatened. The cultural work, then, is to foster aesthetic literacies that honor planetary function, to re-educate taste towards systems that hum with ecological diversity. There is an emotional repertoire to these aesthetic encounters that repeats in testimonies across cultures. The first is awe, a sense of being held in a larger process that precedes and will outlast individual lives. Awe can be expansive, dissolving egocentric frames and widening moral concern. A second is mourning, the sharp grief for landscapes altered or lost, for species that no longer vocalize in the dawn. A third is wonder, a curiosity that binds study and care. These affective tones are not purely sentimental, they are motivational. They are the emotional infrastructure of any collective attempt to steward the planet. Beauty without commitment can remain voyeuristic. A wonder without tools is helpless. The narrative that connects aesthetic reaction to sustained practice is therefore crucial. That connection can be mediated by ritual and by slow cultural forms that anchor attention across generations. The preservation of a wetland or the restoration of a coral reef requires patient schedules, budgets, and policies, but it also requires that a society keep that place within its aesthetic repertoire, in its stories and ceremonies, so that political will does not wither. The aesthetic rhythm becomes civic infrastructure. Festivals, educational programs, art commissions, and landscape architecture that celebrate planetary rhythms are ways of translating ephemeral feeling into durable public goods. The planet's beauty thus becomes the seedbed of political action. In the background of this aesthetic reflection sits the unsettling possibility that human bursts of invention, cities, lights, radio signals, are transient pulses in a planetary nervous system that does not depend on them. Civilizations can flare and fade, leaving faint chemical and stratigraphic trace. That thought should produce neither nihilism nor triumphalism. Rather, it accentuates a kind of modesty. Human achievements register in the planet's archive unevenly, sometimes erased by subduction or sedimentation, sometimes preserved as anomalous isotopic or material fingerprints. The aesthetic does not require permanence to carry moral weight. The decision to care for a place, a species, a climate regime is significant even if the physical trace of that care dissolves in deep time. The value resides in the relationship itself, the practice of attuning to rhythms that extend beyond immediate lifespans. This is the documentary's appeal, to convert the sublime image of a glowing, full-bodied Earth into a practical insistence on listening. Aesthetics becomes method as well as motive. The viewer is asked to practice perception calibrated to the planet's tempos, to notice seasonal transitions, to learn how rivers change with a landscape's health, to recognize that a once luminous reef, dimmed over decades, is not merely an ecological failure, but an aesthetic impoverishment. By refining perception, by cultivating a taste for sustainable configurations, humans can align the micro-tempos of daily life with the macro-tempos of planetary regulation. The final, urgent chord of this reflection is both simple and hard. Seeing the Earth as a luminous, living sphere is an invitation, not an ending. It invites the cultivation of long attention, an aesthetic discipline that resists spectacle and instead invests in the slow accumulation of care. The planet's rhythms are neither purely gentle nor forever forgiving. They will respond to perturbations with adjustments that may not match human hopes. Yet the capacity for repair exists in pattern and practice. Wetlands can be rewoven, forests re-established, and soils restored. The aesthetics of repair need not be picturesque in a postcard sense. They will often be messy, irregular, and physiologically sensible, mosaics of managed wildness rather than manicured control. In that messy, patient work lies a new kind of beauty, an aesthetics of resilience. The narrator leaves this part with a last image: the globe at night, a slowly rotating sphere, light pulsing in waves across continents, cloud bands rolling like the laps of a breathing skin. Within those light patterns are millions of small decisions, switches left on at dawn, rivers dammed, fields left fallow, cities darkened in careful conservation. Each decision adds a mote to the planet's sheen. Seeing the Earth as an organism is not to ascribe literal thought to geology or to claim a cosmic mind speaks through auroras. It is to suggest a posture, an aesthetic and ethical posture, that transforms vision into responsibility. The glowing organism below is beautiful. It is also, in its beauty, demanding. The intimacy it inspires asks of any species that inhabits it not only to watch and to marvel, but to listen and to care. What if an earthquake is not a capricious disaster, but a cough, a sudden expulsion of pent-up strain in a body that must move to survive? What if a volcanic eruption is less an act of random fury and more a feverish flare in a system that needs to rebalance? Heat and chemistry? These provocative images set the stage for an act that is at once theatrical and intimate, the tectonic theater, where plates perform, where lava writes in ink of fire, and where upheavals are the organism's way of adjusting its own fragile order. The stage is vast, folded into seams that march across the globe. Plate boundaries are not mere lines on a map. They are living sutures where the Earth's outer shell is being stitched and unraveled. At divergent margins, new lithospheres born as mantle upwells and basaltic flows cool into crust. At convergent margins, one plate bends and slides under another, a slow ingestion that feeds the mantle and feeds back into surface topography. Transform faults of the tendons that allow plates to slide past each other, sometimes peacefully, sometimes with violence. From the point of view of an organism, these boundaries are joints and muscles, the ways the planet rearranges its outer form, relieves internal stress, and reconfigures its surface in response to energy gradients and mass imbalances, to drama. The visible, explosive drama centers on two kinds of convulsion: volcanic eruptions and earthquakes. Both feel, to human perception, like assaults. They arrive without warning and with an immediacy that collapses human schedules into seconds. But the underlying mechanics are patient, subterranean processes that accumulate and then release. In that patience lies a moral and epistemic lesson. What looks abrupt on a human clock is often the terminal expression of processes that have been evolving for millennia. Consider the life cycle of a volcano as a physiological episode. Deep inside, heat rises from the convecting mantle. Pockets of melt coalesce in magma chambers, changing composition through differentiation and infusion of volatiles. Pressure builds like fever, dissolved gases expand, fractures form, and the system becomes ripe for release. Long before lava touches air, there are subtle signs: a swarm of tiny earthquakes, a swelling of the ground like a skin puffing with breath, an uptick in sulfurous gases escaping through fumaroles. These are the premonitory notes that attentive instruments can read, the nervous system twitching before a convulsion. When eruption occurs, it does so in forms that speak of the internal condition. Effusive eruptions, the gentle outpours of basalt that build shield volcanoes and flood basalts, are steady exhalations. They reshape terrains slowly, layer over layer, creating vast plateaus or adding new rock to ocean floors. Explosive eruptions, where viscous magmas lock gases until pressure tears them apart, or fevers writ large columns of ash and gas loft into the stratosphere, sunlight filtered into a dim twilight, aerosol spreading like a planetary palette wash. Pyroclastic density currents, the incandescent flows of ash and gas, rush across landscapes with terrifying speed, rearranging surface topography, stripping vegetation, and burying life beneath sterile tephra. The atmospheric consequences are not incidental. When certain eruptions inject sulfates into the stratosphere, they alter planetary albedo. The world cools in the years after a major eruption. Crops fail in regions far from the vent. Migratory patterns change. These are not just local calamities, they are systemic responses. The atmosphere and biosphere react to the chemistry poured into the air. But there is a countervailing effect. Volcanic ash and nutrient-rich tephra fertilize soils, triggering blooms of life in the geologic aftermath. The same event can be both destructive and regenerative. Immediate harm and long-term enrichment, a reminder of the ambivalence woven into planetary adjustments. Earthquakes, too, carry a dual meaning. At the interface of stuck plates, strain accumulates over decades to centuries. Rocks deform elastically, bending like a limb under load. Then, when friction gives, a rupture propagates along a fault at speeds astonishing to imaginary scales, kilometers per second, releasing energy in waves that travel through the crust. The ground lurches, buildings fall, a coastline lifts or drops by meters. In subduction zones, this displacement can displace entire volumes of water, generating tsunamis that race across oceans, flattening shores far from the initial rupture. It is easy to see these phenomena as random malice. It is harder but more accurate to see them as functional. The planet-relieving stress accumulated by slow, inexorable motions. There are rhythms to these events. Some zones are persistently active, like the Pacific Ring of Fire, a place where subduction, volcanism, and seismicity conspire to make a long, leashed display of tectonic energy. Other regions, far from plate margins, are quiet for eons until a sudden reactivation occurs, often linked to mantle plumes or far-field stresses. Large igneous provinces, massive flood basalt events are episodic, monstrous exhalations that over geological spans pour out volumes of lava capable of modifying atmospheric chemistry and triggering extinctions. The repetition of these episodes and their clustering in time are part of the planet's recipe for long-term reorganization. This reframing, seeing upheavals as physiological adjustments, alters emotional response. The initial shock that fear brings is accompanied, if one listens long enough, by a different note: respect. An earthquake is not a punishment delivered by caprice. It is a symptom of the planet's ongoing maintenance. A volcano is not mere destructive whimsy. It is a necessary valve for heat and volatile exchange. Recognizing this does not lessen human suffering in the wake of these events. It rather situates those tragedies within a larger, more patient narrative. The challenge is then to design human institutions capable of both mourning the losses and understanding the systemic processes that produced them. The aftermath of tectonic upheaval is rich with geological and ecological consequences. The deposition of ash and tephra alters soil chemistry profoundly. Volcanic soils, after weathering, can be extraordinarily fertile, fostering agricultural richness in the long run. Mountains raised by orogeny, the slow, grinding collisions that uplift ranges, create rain shadows, delineate climates, and sculpt biodiversity gradients. The Himalayas' rise changed monsoon dynamics and shaped the evolutionary pathways of thousands of species. Subduction zones recycle crustal materials into the mantle. They also bring carbon back into the surface environment through arc volcanism. In other words, the tectonic theater is integrally linked to the carbon cycle, nutrient redistribution, and the very possibilities for life. But upheaval can also be catastrophic in its ecological consequences. Large, rapid injections of aerosols or greenhouse gases have precipitated mass extinctions in Earth's history. The end Permian and end Cretaceous events, each with distinct causes and expressions, testify to the planet's capacity to transition into inhospitable states. The common thread is not malevolence but coupling. When one subsystem, volcanism, climate, ocean chemistry, nudges another past a critical threshold, cascading failures can ensue. These are the planetary fevers that push biospheric configurations toward new baselines. There is also memory and erasure baked into these upheavals. Catastrophic events can both create exceptional fossilization conditions and erase records through erosion and recycling. Rapid burial in ash can preserve soft tissues in extraordinary detail, as in certain volcanic Lagerstätten. Conversely, orogenic uplift and subsequent erosion can obliterate entire sedimentary archives. The planet's capacity to both record and erase its own history complicates any attempt, whether scientific or speculative, to raid past civilizations or biological states from the rock record. Where tectonics is vigorous, the archival record is paradoxically thinner. Where tectonics is staid, sediments lie patiently, writing long histories in quiet layers. That paradox feeds a speculative humility. If the planet is a patient organism that restructures itself, it is also an effective forgetter. Entire epochs can leave only ghostly chemical hints among rocks that have been partially remade. For any intelligence that seeks to understand its deep past, the tectonic theater is both a source of data and an agent of erasure. The implication is unsettling. Much of what the planet has done in its earlier instance may simply have been consumed by the processes that make it possible for later complexity to arise. Human cultures have long absorbed tectonic theater into their myths and rituals. Volcanoes are personified as gods or demons. Earthquakes are explained as monsters stirring beneath the ground. These narratives, however literal or allegorical, are cultural techniques for making sense of unpredictability. In a different key, modern science translates the same motions into seismic hazard maps, eruption forecasts, and building codes. The transformation of fear into predictive frameworks is not merely technical, it is moral. It speaks to the capacity of societies to adapt, to learn what patterns to heed, to invest in resilience, to redesign infrastructure in concert with geological realities. In recent times, human activity has begun to intrude back into the tectonic equation. Reservoir-induced seismicity, earthquakes triggered by the loading of large dams, and the seismic effects of fluid injection in industrial processes demonstrate that even modest perturbations in stress fields can nudge the planet into motion. This is a sobering reminder. The Earth's crust, while majestic, is finely balanced. On human timescales, the addition of large masses of water or the injection of fluids can alter pore pressures, lubricate faults, and precipitate slips. This does not mean that civilization can commandeer tectonics at will. Rather, it means that anthropogenic actions can sometimes have outsized and unexpected geophysical consequences. From a planetary perspective, the most consequential anthropogenic perturbation is climate change. As ice sheets shrink and sea levels rise, loads on the crust redistribute, isostatic adjustments alter stress fields subtly but detectably. Permafrost thaw and groundwater extraction change pore pressures. In sum, human-induced changes in mass distribution and fluid states can intersect with tectonic processes in ways that increase hazard in some places and decrease it in others. These are second-order effects, but they underscore the entanglement of human systems with deep Earth systems. The aftermath of major tectonic events also rewires biological opportunity. Following a mass extinction, the biosphere often experiences pulses of adaptive radiation. Vacant niches are colonized, morphological experimentation accelerates, ecological networks rearrange. The fossil record shows cycles in which devastation is followed by bursts of innovation. Seen in the long view, calamity and creativity are braided, upheaval prunes, and evolution regrows. This is not consolation for loss, but rather an observation of the planet's resilience mechanisms, the ways in which life exploits new regimes to reconfigure itself. The theater's dramaturgy also includes slow, unglamorous processes, the grinding, invisible creep of sediments into basins, the steady metamorphism that converts organic carbon into long-buried hydrocarbons, the slow uplift that tilts a drainage and reroutes an entire ecosystem. These are the background motions that accumulate to produce future shocks. They are the maintenance work of the planetary body, the everyday physiochemical exchanges that keep the system within bounds. Their monotony belies their significance. A single centimeter of subsidence across a delta can, over centuries, change flood regimes and human settlement patterns fundamentally. At a moral register, the tectonic theater demands a particular humility. Humanity's lifespan is a flicker against the metronome of plates and plumes. Technologies can mitigate vulnerability, seismic-resistant construction, early warning systems, land use planning, and stewardship can reduce exposure, preserving forests that stabilize slopes, protecting wetlands that dissipate tsunami energy, and avoiding settlement in active alluvial fans. Yet these measures are gestures toward cohabitation, not domination. The planet will continue to convulse, to cough and fever, as it has done across eons. The ethical task is to live with awareness, to design societies that can endure the regular realities of a dynamic crust without preventing the slow, necessary operations that sustain long-term habitability. In the wake of a major upheaval, the narrative that follows can be elegiac or generative. Ash layers create new soils, valleys deepened by landslides become corridors for new rivers, calderas refill with lakes that become wildlife havens. The Earth's ability to rework devastation into novel niches is a theme repeated across deep time. It is not a guarantee of continuity for any particular species, culture, or artifact. It is rather the planet's way of re-establishing gradients and interfaces where life can re-emerge, given time and opportunity. The tectonic theater is thus both spectacle and service. Its convulsions are not merely calamities, they are physiological acts, the slow shuffles and sudden coughs of a planetary body that must redistribute mass, release heat and volatiles, and rebuild its surface. To live on such a planet is to be perpetually neighboring dynamism, to build, to move, to respect the seams, and to design institutions that translate the planet's ancient logic into humane adaptation. The elegance of this insight is chilling. The same forces that create fertile soils and towering ranges can also, without irony, erase entire cultures. The imperative for the present generation is to recognize that terror and beauty are not opposites in this theater, but co-authors of the same unfolding script, and so the aftermath, the consequences, is both practical and philosophical. Practically, societies must integrate geological knowledge into planning, governance, and cultural memory. Philosophically, they must absorb a posture of listening, learning to read a swarm of small quakes as a whisper of an impending rearrangement, recognizing that a slow uplift may herald flood risk centuries hence, acknowledging that a volcanic bloom of productivity for future agriculture may be preceded by immediate devastation. The tectonic theater compels a relationship with time that is not impatient or triumphalist. It asks for practices that combine care, resilience, and an ethic of coexistence with a body much older and larger than any civilization that will ever step upon it. In the next chapter, the voice will move inward to the interface where tectonics and life meet most intimately, the coastal margins, the river deltas, and the shallow shelves where fire and water, rock and organism meet and negotiate. For now, the listener is left with a last image, a map lit not only by human settlements but by the lines of lithospheric seams. Those seams whisper of motion, of pressure and release, of a planetary system that breathes and convulses. To inhabit that map is to accept that the stage will always be tectonic, and that the actors, continents, seas, organisms, and human societies, must learn to move in tune with a theater older than their scripts. What does loss look like when measured in strata rather than in days? What does grief sound like when its drumbeats are measured in millennia instead of lifetimes? The question changes the scale of mourning. It invites a listener to imagine extinction not as an abrupt end of familiar forms, but as a recurring rhythm in a planetary score, a contraction and regeneration, a hemorrhage and clotting in the body of the earth. In that large, slow theater, life rises with brushes of green and microbial shimmer, then recedes under tides of chemistry and climate, only to renew in new shapes. The chapter opens with that cadence. Life grows, collapses, and is reborn as part of a physiological circulation, as if the planet itself were periodically flushing and renewing its inner milieu. From the vantage of deep time, extinctions are not simply failures. They are reconfigurations. Some are narrow and surgical, removing fragile lineages. Others are wholesale ruptures that dismantle entire ecologies. Again, the Permian, for instance, is a sobering example of planetary-scale crisis, a cascade of volcanic outgassing, ocean anoxia, and greenhouse warming that wiped out a great proportion of species. The Cretaceous Paleogene boundary provides a different lesson, an extraterrestrial blow that reset ecological tables and cleared room for mammals to radiate. Ice ages repeatedly rearranged biogeography, compressing ranges into refugia and then letting forests and savannas spill back out. Each event readjusted the planetary biochemistry, altered feedback loops, and changed the ratio of niches to actors. To call these events merely catastrophic is to miss their generative afterlife, the reshaping of opportunity, the opening of ecological space, the reallocation of energy gradients that new life could exploit. Seen through this lens, the planet appears to be experimenting. That is a provocative phrase and must be held gently. The Earth does not plan in a human sense. There is no conscious jury sitting in the mantle, weighing which clades deserve another epoch. Rather, the narrative that treats planetary systems as trying to rebalance is shorthand for a set of emergent processes, feedbacks, thresholds, and reorganizations that alter which configurations of life are stable. When atmospheric composition, ocean chemistry, and thermal gradients shift, certain metabolic strategies flourish while others wither. Over successive episodes of disruption and recovery, different ensembles of species become the instruments through which energy and matter flow. In that sense, the planet's history reads like an experimental archive, a series of conditions tested, some stable and persistent, others ephemeral, each one a contribution to the space of possible biological orders. The image that accompanies this reflection is intimate and corporeal. Extinction can be read as the body shedding diseased tissue or sloughing an old epidermis, painful, frightening, and yet structurally sensible. A coral reef that bleaches and collapses returns, after time and under different conditions, to new forms of coral, or to eelgrass meadows that occupy the niche the reef vacated. Forests, after fires or fungal waves, sprout pioneer species whose fast metabolism alters soils and microclimates, paving the way for later successional communities. These processes are not simply cycles of loss and regeneration, they are transformations in which the planet's chemistry is reassembled, new feedbacks are established, and the homeostatic set points of climate and ecosystem services are subtly redefined. There is, woven into these dynamics, the notion of planetary homeostasis as trial and error. The systems that mediate climate, carbon cycling, nutrient flux, ocean uptake, albedo, do not possess a single target value to maintain. Instead, they embody a network of interdependent equilibria that can be shifted by sedimentation, tectonics, evolution, and stochastic events. When one element moves, when a series of basaltic eruptions injects vast quantities of CO2, or when a runaway methane release warms oceans, the network explores new states. Some states recalibrate and return to a prior regime. Others bifurcate into long-term climatic modes unlike what preceded them. Conceived poetically, the planet is continually trying on different internal states, seeing which arrangements of gases, waters, and biota produce stable functioning over geological spans. The experiments are neither moral nor intentional. They are the physics and chemistry of massive coupled systems. Yet the outcomes read like an empirical history of what configurations will sustain complex, diverse life for extended periods. This metaphoric laboratory contains a disquieting implication for the human species. For most of its existence, life experienced slow reweavings of community. Evolutionary change and ecological succession were paced by gradients measured in tens of thousands to millions of years. Human industry, by contrast, has concentrated perturbations into mere centuries, burning ancient hydrocarbons, acidifying the ocean, fragmenting habitats, and rearranging nutrient cycles at unprecedented speed. When a planetary system was exploring a new equilibrium over millennia, humans now add a sudden, noisy experiment to the matrix. The result is a collision of timescales, slow, patient reconfiguration versus abrupt, externally forced change. The ensuing disequilibria are experienced as loss and dislocation by beings whose lifespans are short enough to feel them. The ethics of loss in this frame become complex. Grief is not merely an emotional reflex, it is also an epistemic resource and a social technology. Societies have always encoded mourning in ritual and story, but the current epoch may call for new forms of collective grieving, practices that translate private sorrow into durable public commitments. The philosopher's question is stark. What does it mean to grieve for extinctions that proceed on mixtures of human and non-human? Causation, when those extinctions reshape the very conditions of future life. The answer that emerges across cultures and histories is not singular. Grief can be corrosive if it becomes despair, it can be ennobling if it channels sorrow into action, and it can be clarifying if it uncovers what was interdependent in the first place. There is a political edge here. Losses that are socially distributed following a climatic or ecological rupture reveal, with brutal clarity, the moral contours of vulnerability. The species, communities, and habitats that pay the heaviest toll are not randomly chosen. The most sensitive and the least mobile are often the first to vanish. The poorest and least powerful human communities tend to bear disproportionate burdens. In that sense, planetary experimentation is not indifferent to justice. The ethical response must therefore be an amalgam, deep mourning for the irretrievable, practical measures to protect the vulnerable, and institutional changes that reduce the likelihood of catastrophic experiments being forced upon the biosphere. Memory, too, is reworked by these cycles. Geological processes both conserve and erase. Where an extinction event is sudden and burying, as with certain volcanic ash falls or catastrophic floods, it can produce exquisite fossil records that preserve details of vanished life. More often, the slow churn of plate tectonics, erosion, and sedimentation eats away at biological archives. Thus, much is lost not only biologically but historically. Entire chapters of ecological story are consumed, their traces overwritten. This double erasure of life and its record complicates any attempt to reconstruct the forms that once were. It also compounds grief. One cannot fully mourn what one barely remembers. The consolation is small but real. Some signatures persist. Isotopic anomalies, shifts in mineral deposition, molecular fragments embedded in resistant matrices, and these fragments are the breadcrumbs that let later investigators peer backward into the lived realities of vanished ecologies. One of the most nourishing perspectives is to see extinction and rebirth as needed resets in certain circumstances. Ecosystems that become rigidly locked into states that produce high fragility can be reset by disturbance. Fire, flooding, and disease, though terrible in particulars, can open ecological space, re-establish heterogeneity, and allow for adaptive radiations. This is not an argument for welcoming destruction, nor for treating loss as acceptable collateral. It is, rather, an acknowledgement that disturbance is woven into the fabric of Earth's dynamics. The moral work is to distinguish between disturbances that are naturally integrated into system resilience and those that are rapidly imposed and likely to push the system into novel, impoverished states that do not support the diversity on which long-term resilience depends. There is an understated humility that follows this thinking. Humans are contributors to the planet's repertoire of perturbations, but they are not the only forces at play. To recognize this is to expand responsibility beyond immediate repairs to an orientation towards systems-level resilience. That orientation prioritizes the protection of functional diversity, wetlands that filter water and sequester carbon, intact forests that stabilize soils and retain microclimates, river corridors that permit species migrations when climates shift. These are the infrastructural tissues of planetary homeostasis. Protecting and restoring them is not merely sentimental conservation, it is a practical investment in the stability of the conditions that support complex life. Grief, in a civic register, can be ritualized into durable practice. A society that mourns a species might fund habitat restoration, legislate protections against habitat destruction, or change agricultural and urban practices to reduce pressures. Grief can also shape cultural narratives that teach the next generation to value interdependence and to reason in longer temporal spans. The transformation of sorrow into policy and practice is not inevitable. It depends on narratives, institutions, and collective energies tuned to the long game. There is, finally, a contemplative strand to this philosophy of loss. The aesthetic and moral response to extinction is not only instrumental, it also touches questions of meaning and belonging. When a species disappears, a particular, unrepeatable mode of being in the world vanishes, an arrangement of perception, metabolism, and relationality that had its own internal logic. For humans, whose imaginations are entangled with other lives, that loss can be existential. The planetary scale reframes that existential sting into a pathway. The recognition of human finitude invites a deeper humility about agency and a recalibration of ambition. Accepting limited power does not require passivity. Rather, it demands careful, patient craft. Indeed, stewardship under deep time is less about domination and more about tending, planting, protecting, restoring, and living with a sense of finite intervention. As this chapter closes, the image returning to the listener is a palimpsest. Layers of life and loss washed over by geology's indifferent hand, the memory traces of ancient biospheres encoded in isotopes, and mineral fabrics, the intermittent bursts of diversity that followed each planetary convulsion. The Earth's experiments in homeostatic arrangement have been both cruel and productive. They have produced the conditions for consciousness, artwork, and ecosystems, as well as the mass graves of lineages that once flourished. In the face of that history, the ethical challenge is not to halt the planet's experimentation, that is impossible, but to cease adding reckless experiments of a scale and rapidity that threaten to erase the careful balances evolved over eons. The final mood is sober, neither despairing nor triumphant. Loss is real and sometimes irreversible. Grief is necessary and potentially generative. The philosophical posture that the narrator asks the listener to consider is one of attentive lamentation coupled with disciplined care, to mourn precisely, to remember widely, and to act with an appreciation for the deep temporal architecture of the planet. The next chapter will press this thread further, moving from the broad vision of cycles and grief into the more focused question of how a planetary system, in its attempts to rebalance, leaves signals, chemical, electromagnetic, structural, that could be read as attempts at internal regulation. It will examine what those signals look like and how a species with the audacity to observe might learn to listen without presuming purpose where none may exist. For now, the listener is left with the sense that life's rise and fall is a bodily rhythm of the earth, a sequence of growth, hemorrhage, and renewal that both wounds and regenerates, and that calls for an ethic fit for the durations it demands. Can a planet think? Or more precisely, what would it mean if the earth, taken as a whole, were more than a complex machine, if it were, in some meaningful sense, a cognitive system? That question sits at the edge of human knowing, and it does so not because of a lack of clever instruments or audacious imagination, but because of the structural limits built into how minds, human minds in particular, recognize other minds. The problem is older than satellites and ice cores. It is the old philosophical problem of other minds cast onto a scale for which ordinary criteria of cognition are profoundly ill-suited. On the street level of intuition, the easiest move is to anthropomorphize. Biological humans see pattern, intention, preference. They read faces in clouds and motive in weather. That reflex has a utility. It tunes attention to agency in social environments where detecting intention could mean survival. But the reflex also misfires when its heuristics are stretched across orders of magnitude. The earth does not sit in a chair and smile. It does not articulate propositions. It has no cortex to be scanned for activity, no synaptic spiking that can be held up as a definitive token of consciousness. Its processes unfurl across kilometers, centuries, and chemical gradients. The epistemic boundary is simple to state and devilishly hard to cross. Human cognition evolved to infer minds from the behavior of other animals and people, entities that operate on similar timescales, whose causal signatures are immediately comprehensible. The Earth's potential behaviors do not fit those patterns. Philosophically, responses to this problem divide into several families. One camp insists consciousness is tightly tied to neural architecture, the wet, excitable tissue of brains arranged in particular ways, a substrate-anchored view. Another camp leans toward emergentism, complex, appropriately organized systems of information. Processing might, under certain conditions, instantiate conscious states even without neurons. Between and around them creep a host of intermediary positions, panpsychism suggesting a ubiquitous proto-experience woven into matter, extended mind theories that distribute cognitive processes across organism and environment, and systems perspectives that treat cognition as the capacity of a coupled network to generate integrated, history-sensitive responses. Each hypothesis carries strengths and problems. The brain-bound view has empirical heft. Neuroscientists map correlations between conscious states and neural dynamics, and interventions in the brain reliably alter subjective experience. This gives confidence that some necessary conditions for consciousness are neural. But is neuroscience sufficient to exclude other architectures? Emergentists argue it is not. They point to general features associated with subjective systems, integration of information across subsystems, causal globality, where parts influence the whole and vice versa, history dependence, memory, and a capacity for sustained self-differentiation from background noise. These are formal properties, not molecular ones. If a system as large as Earth were to realize them, the claim goes, the substrate might not matter. To make these ideas less abstract, imagine two axes. On one axis sits complexity, the number and richness of interacting components and feedbacks. On the other sits integration, the degree to which those components cohere into a system whose parts mutually constrain one another. A brain scores high on both. A rock scores low on both. The planet sits in an ambiguous middle. It is staggeringly complex. Its parts are richly coupled through circulations of heat, water, and chemistry. But the degree of integration, the way local processes are bound into a single, irreducible global state that exhibits unified good-making or bad-making properties, is the crux. Does the planetary system exhibit enough causal closure and unity of function to be read as a cognitive agent? There are attempts in scientific and philosophical circles to formalize such intuitions. Integrated Information Theory, IIT, for example, proposes a quantitative metric, phi, intended to measure how much information is integrated across a system. High phi values, IIT suggests, correlate with high levels of consciousness. Applying such measures to the planet is conceptually seductive but practically fraught. Measurement is the immediate stumbling block. Calculating phi for a brain already strains present techniques. Doing so for the Earth, which includes seas, atmospheres, soils, microbial communities, and human technosystems, is currently impossible in any concrete sense. Even if one could, interpretation would be contested. Does a high phi for a planet imply something like feeling, or only a formal unity of causal interactions without the qualitative interiority associated with subjective experience? Other thinkers propose different signatures of systemic mind, patterns of coordinated global response that cannot be reduced to local causation, synchronous shifts across latitudes, temporally linked transformations of aerosols, biogeochemical coupling manifesting as shifts in global states, are sometimes invoked as candidate behaviors. But here the problem is one of parsimony. Self-organization and emergent order produce coordinated change without any intentional steering. The curious formations of hurricanes, the blooming of oceanic phytoplankton following remote upwelling, or the quasi-periodic oscillations of climate modes are remarkable, but they do not necessarily entail agency. Non-intentional systems can and do calculate, predict, and regulate. They do not thereby become minds in any richer sense unless one modifies the definition of mind itself. Practical epistemology must therefore start with humility. The methods of science excel at isolating mechanisms, building models that reproduce observed dynamics, and predicting their near-term consequences. They are less adept at adjudicating whether a pattern of dynamics constitutes inner experience. That category, subjective experience, resists externally derived measurement. It is a private, qualitative dimension. The one route humans have toward other minds is analogical inference. Behavior suggests internal states. But on planetary scales, behavior is ambiguous. The same observed Pan. A global return to a steady climate state could be interpreted as homeostatic regulation, as merely the physical system finding a basin of attraction, or, in a bolder frame, as a kind of global problem-solving. Distinguishing among these requires theoretical restraints that human knowledge can scarcely provide. That epistemic boundary has immediate, ethical, and heuristic consequences. A sober stance recognizes 2 points. First, humans cannot, at present, know whether the Earth thinks, in any literal sense comparable to conscious organisms. The archival record, the equations of fluid dynamics, and paleoclimate reconstructions do not bridge the explanatory gap between functional organization and subjective interiority. Second, whether or not the planet possesses consciousness, it exhibits behavior patterns and feedbacks that impact human welfare decisively. For moral and practical purposes, these 2 points converge. Uncertainty about planetary mind should not paralyze policy. The precautionary principle and a systems-aware ethic argue that humans must behave as if they are embedded within a larger, responsive substrate whose dynamics will be affected by human action and where, in any event, the costs of recklessness are irreversible. This leads to a critical contemporary theme. The present moment in Earth's history is not a neutral background against which philosophical debates about planetary cognition can be settled. The Anthropocene, the era in which human activity becomes a dominant force shaping planetary systems, alters the conditions of inquiry. 2 things happen simultaneously. Humans, through emissions, land use, industrial chemistry, and biosphere alteration, inject rapid perturbations into slow geological and ecological processes. At the same time, humans are constructing an ever denser sensorium, satellites, ocean floats, atmospheric networks, and a planetary-scale internet that remaps information flows in unprecedented ways. In a sense, humanity is both perturbing the system and extending its observational reach, as if the species were fumbling awkwardly toward a kind of planetary nervous system it neither fully understands nor controls. That dual role introduces a new speculative possibility. If cognition is a function of information integration across coupled systems, then the technosphere, the global mesh of machines, communications, and socio-economic networks could alter the Earth's integrative profile. Human-built networks process, redistribute, and amplify signals in ways that were formerly impossible. Power grids, shipping lanes, global markets, and digital platforms create channels for rapid, coordinated action at planetary scales. They also feed back materially. Energy use alters thermal regimes. Material extraction reshapes geology. Information flows change. Behaviors that affect land cover and resource consumption. The technosphere thus functioned as a new organ within the Earth system, one characterized by high-velocity information exchange and intentional planning. Whether this addition makes the entire system more likely to achieve the criteria some associate with cognition, higher integration, richer history dependence, and tighter feedback control is an open question. It is also a question laden with stakes. If human networks increase the Earth's capacities for regulated response, they could theoretically support resilience. If they introduce new vulnerabilities and amplify destructive feedbacks, they could push the planet into destabilized modes. The ethical upshot is not speculative theology, but actionable humility. Whether or not Earth thinks it has capacities and thresholds, whether or not it has interiority, it responds to perturbation. Acting as if the planet were an unresponsive inert stage is demonstrably dangerous. Acting as if the planet were a fellow subject with whom negotiation is possible risks anthropocentric projection. A prudent middle path emphasizes relationship over projection and precaution over certainty. This path includes practices the modern sciences already suggest, safeguarding biospheric and geophysical buffers, restoring ecosystems that provide critical regulatory services, reducing greenhouse gas emissions to limit rapid climate forcing, and investing in institutions that can steward long-term planetary health. There is a parallel moral technology, listening. Listening here is literal and figurative. It is literal in the sense of expanding observation across time and space, more and better sensors, longer data sets, deeper paleoclimatological reconstructions. But it is also figurative, a cultivation of epistemic patience and interpretive restraint. Listening resists quick narrative closure. It admits that some patterns will remain refractory, that signals will be entangled with noise, that causality is distributed and messy. Listening implies that policy must be adaptive, responsive to emerging understanding, and woven into social institutions that can persist across generations. An additional ethical dimension concerns the narratives societies tell. If the dominant cultural script is one of mastery and extraction, then instruments of governance will be designed to accelerate throughput. If the script is one of belonging and maintenance, institutions will bias toward conservation, restoration, and humility before deep time. The question of planetary cognition might never be settled in purely scientific terms, but the stories chosen now will shape the likelihood that Earth's long-term dynamics remain hospitable to complex life. Here the philosophical and the political intersect. Uncertainty about whether the planet thinks should not be a license for indifference. It should be a prompt to redesign human systems so they are attentive to interdependence and scale to deep-time consequences. Finally, the speculative documentary voice must insist on a moral image. Whether the Earth harbors interiority is less immediately consequential than the reality that the species most capable of, altering its trajectories is now in control, however haltingly, of planetary inputs. The practical question is not metaphysical confirmation of planetary mind, but whether humanity can develop the restraint, foresight, and institutions to live within Earth's tolerances. That requires cultivating reverence for long durations, embedding precaution into the architecture of power, and imagining governance as a form of extended care rather than conquest. To conclude, the limits of human cognition are structural. The inference of mind relies on analogies that break down across scales. The Earth might be an integrated, history-sensitive system with emergent properties that parallel cognitive features, or it might not. The relevant ethical stance is robust under both possibilities. Act as if one is part of a living, responsive world, and design institutions and practices that repair rather than rupture the vast processes on which present and future life depend. In the hush between skepticism and wonder, there is a practical imperative to listen longer, to measure more patiently, and to steward more carefully. The planet may or may not think, it does in any case remember and respond. Humans can choose whether to be nurses at that bedside, attentive to its fevers and breaths, or to continue as reckless tenants who risk extinguishing the very patterns that made cognition and culture possible. The final question, then, is not purely epistemic. It is moral. In the face of vast uncertainty, what sort of species will humanity choose to become? What if the climate crisis is not merely an accumulation of statistics and calamities, but a kind of message, a persistent, rising modulation in the planet's long conversation with itself? That question refracts into a dozen smaller assumptions, each of them provisional and instructive. The exercise of laying those assumptions out is not an attempt to claim certainty. Rather, it is a disciplined way of imagining what kinds of worlds might be sensible to build in response. In the space between data and meaning, speculation can be methodical. It sets boundaries, names possibilities, and clarifies the moral choices that follow. First assumption: the planet signals through feedbacks, not sentences. If the Earth were sending messages, they would arrive as shifts in marginal conditions, changes in fluxes, frequencies, and variances, rather than as propositional statements. A warming trend is not an admonition in human language. It is a sustained alteration of boundary conditions. Resource depletion reads like a reduction in available margins. Soils become impoverished, aquifers thin, fossil stocks fall. Interpreting these as signals requires a shift of attention from events to processes. A signal in this sense is an alteration in the patterning of flows that previously maintained habitability. The implication is practical. Humans must learn to read gradients, the creeping increase of ocean heat content, the incremental rise in atmospheric greenhouse gas concentrations, the slowing of deep currents, with the same seriousness with which clinicians read blood chemistry. The grammar of planetary communication is statistical, systemic, and slow by daily standards. What looks like noise may be the beginning of a sustained, state-changing message. Second assumption: the Earth's voice is multiplex. Multiple subsystems speak at once: atmosphere, cryosphere, hydrosphere, lithosphere, biosphere, and the emergent technosphere. Each has its own tempo. The atmosphere breathes in decades to centuries. The mantle circulates over millions of years. Carbon flows move on timescales, from seasonal uptake by phytoplankton to the burial that takes millions of years. Interpreting signals, therefore, demands a polyphonic listening strategy, instruments and institutions that can hear both the quick, panicked pulses and the long, steady rumblings. This multiplex quality explains why single data heuristics fail. A decrease in sea ice in the Arctic is not an isolated cry. It is entwined with albedo feedbacks, atmospheric jet stream changes, permafrost thaw, and ecological rearrangement. Treating any one of these as the entire message risks both alarmism and complacency. Third assumption: depletion is a boundary reminder. Resource exhaustion is not merely an economic problem. It behaves like a physiological signal that a tissue is being overdrafted. Groundwater declines in an agricultural basin can be read as a local anemia. Extraction outpaces recharge, pores collapse, wells go dry. On a planetary scale, the drawdown of long sequestered carbon, fossil fuels, is analogous to bleeding stored energy out of a body. The timing is crucial. Stored carbon accumulated across geological epochs. Its rapid combustion in centuries remixes atmospheric chemistry far faster than the slow feedbacks that once buffered changes. The planet, in return, alters climates, precipitation regimes, and ocean chemistry. Conceptualizing resource depletion as a boundary reminder invites stewardship models built around renewability, replenishment, and the recognition that some storages were never meant to be spent in a human career. Fourth assumption: not every response is communication. A volcanic eruption or hurricane is not necessarily an attempt to speak. Most of the time, it is the material consequence of energy redistributions. But that distinction between causal, non-intentional response and communicative signal may be less relevant to human decision-making than it is to metaphysics. Regardless of intention, the material effects demand response. A society listening to the planet must be prepared to act on both kinds of events, those that are symptomatic of broader systemic states and those that are localized but devastating. Practical responsiveness thus decouples the question of intention from the workloads of adaptation and mitigation. Fifth assumption: misinterpretation carries risk. The human tendency to anthropomorphize leads to two mirrored errors. Either the species projects human motives onto planetary processes, mistaking complex physical interactions for purposeful correction, or it reduces planetary dynamics to a merely inert backdrop, excusing reckless behavior because the Earth will handle it. Both stances are dangerous. The first breeds magical thinking, policy enacted in the belief of a forgiving planetary will, and the second breeds hubris. Sound practice requires an epistemic modesty to treat planetary signals as meaningful alterations requiring correction, without presuming they are moral judgments or that they can be bargained with. Sixth assumption: the technosphere is a new organ that both amplifies and distorts signals. Human-built networks, energy infrastructure, supply chains, digital platforms act like high-speed neural tissue grafted onto a slow-growing organism. These networks transmit influence at near instantaneous rates and concentrate impacts spatially and materially. They also create novel feedbacks. For example, a globalized supply chain tightens the coupling of distant ecosystems and economies. A drought in one region produces ripples in commodity prices that in turn alter land use decisions elsewhere. In speculative terms, the technosphere increases the Earth system's sensitivity to human choices. Listening thus becomes a matter of not only reading natural indicators, but also tracing the loops by which human systems magnify planetary responses. Seventh assumption: precaution is an ethical method. If one accepts that planetary signals indicate changing states with nonlinear thresholds, the precautionary principle becomes an epistemic and moral stance. It is not a prohibition against action, but an injunction to favor reversible and robust interventions when uncertainty looms. This reframes climate policy. Rather than gambling on narrow techno fixes for delayed return, societies might invest disproportionately in repair, resilience, and reversible interventions that lower the probability of crossing catastrophic thresholds. This stance privileges humility in the face of complex coupling. Eighth assumption: communication requires translation across temporalities. Humans operate in electoral cycles, corporate quarters, and lifespans. Planets operate in glacial pulses and orbital processions. Translating planetary signals into tractable policy requires institutions that can carry decisions across generations and that can convert slow metrics into urgent political action. This is not solely a technological problem. It is cultural. Rituals, holidays, and civic education are the cultural technologies that align human attention with planetary tempos. A harvest festival is an ancient example of social alignment to seasonal cycles. Modern equivalents might codify long-term stewardship into binding covenants, trust funds, and constitutional responsibilities. Ninth assumption: the signal of crisis can be reframed as an invitation to reciprocity rather than a reprimand. When boundaries are breached, seas acidify, soils erode, forests shrink, one narrative says the planet is punishing. An alternative is less moralistic and more relational. These are invitations to rescale human practices into systems that respect planetary constraints. Reciprocity here means rebuilding the metabolic loops humans broke, returning carbon to soils, restoring wetlands that moderate floods and sequester carbon, redesigning cities as nutrient cycling hubs rather than waste dumps. This framing shifts the burden from guilt to craft, care as repair work. 10th assumption: listening demands a plurality of knowledges. Scientific instrumentation is critical, but it is not the only valid register. Indigenous ecological knowledge, local weather lore, artisanal agricultural practices, these all encode long-standing, place-specific understandings of system dynamics. A pluralistic approach does not collapse disciplines into a single voice. It recognizes that survival strategies are hybrid. They combine satellite data with riverkeeper testimony, ice core chemistry with the seasonal wisdom of fishers. In practice, this means deliberative governance that privileges both long-run biophysical indicators and the situated observations of communities who live in immediate dependence on local systems. 11th assumption: speculative modeling should be conservative in causal claims and generous in scenario space. The narrator of this speculative documentary insists on two methodological rules. First, avoid asserting teleology. Resist the seductive line that the planet wants a particular state. Second, expand the space of plausible futures, including tail risks. Scenarios must explore not only linear continuations, but also rare, high-impact events and slow, systemic reorganizations. This kind of breadth is a moral obligation. It prevents the narrowing of policy to comfortable projections and forces attention on resilience in the face of uncertainty. 12th assumption: accountability must be planetary and intergenerational. If climate crisis and resource depletion are signals about limits and thresholds, then accountability cannot be restricted to short electoral cycles or corporate accounting years. Institutions must be designed to encode obligations to future biotic communities and to human descendants. Trust mechanisms, long-duration governance structures, and enforceable stewardship charters are speculative imperatives that flow from this assumption. They are the social scaffolding that would allow a species to respond faithfully to planetary messages without treating the moment as a short-term extraction opportunity. 13th assumption: repair is not restoration to a past equilibrium. Some speculative lines imagine an ecological rewind, a return to a pre-industrial baseline. the planet's dynamics, once perturbed, may settle into new baselines indifferent to human nostalgia. Realistic repair is therefore forward-looking. It aims to create systems that function under new boundary conditions, while retaining the capacity to support diverse life and human flourishing. Repair is craft and engineering, but it is also political imagination, designing cities that sequester carbon, agricultural systems that regenerate soils, and economies that privilege circularity over throughput. 14th assumption: signals can be amplified or muted by human action. There is a duality here. Positive actions, reforestation at scale, fossil fuel phase-out, large-scale wetland restoration, can dampen harmful feedbacks and buy time for longer-term adaptation. Conversely, continued high emissions and relentless resource extraction can accelerate the crossing of thresholds and amplify planetary responses. Humans thus occupy both the role of signal reader and the lever. This positionality confers both responsibility and the potential for agency. 15th assumption: the ethical imagination must outpace technical capacity. Technologies to remove carbon, to engineer clouds, or to manipulate permafrost will improve, but imagining their deployment without ethical forethought risks creating novel harms. The principle here is simple but demanding. Technological possibility must be bound to deliberative governance, equitable distribution, and precaution. A speculative orientation that treats planetary crises as signals does not default to techno-solutionism. It insists on democratic stewardship of tools that can reconfigure planetary states. Finally, an integrative assumption: the act of treating the climate crisis and resource depletion as messages changes human behavior. The narrative we accept, whether one of control, punishment, guardianship, or partnership, shapes institutional response. If the climate crisis is a puncture in a tire, the human reaction is to patch, to redesign the wheel, and perhaps to rethink how journeys are planned. If it is read as a cosmic admonition, reaction may be paralyzed by guilt or fatalism. The value of a speculative orientation that lays out these assumptions is that it recenters the question on practice: how to build institutions, crafts, and cultural rhythms that translate planetary feedback into sustained repair. A documentary voice that maps these assumptions does not claim to know the Earth's intentions. It recognizes instead that the planet's present upheavals are meaningful in the sense that they alter the conditions of possibility for life. The climate crisis and resource depletion are signals in the technical sense, changes in a system state that require interpretation and response. Treating them as messages invites a posture of attentive care, instruments to listen, cultures to translate, policies to bind action across time, and ethics robust enough to turn knowledge into stewardship. The speculative exercise, properly disciplined, ends not with metaphysical closure, but with practical insistence. Humans must decide what kind of species they intend to be within a body far older and more capacious than their own. That decision, careful and collective, is the clearest reply to any signal the planet might be sending. If the planet had a mind, would it look at humanity the same way a brain looks at its neurons? The question is meant to startle and to clarify. It is not a metaphysical claim so much as a reversal of perspective. The human tendency is to imagine the world from the vantage of minds that have bodies and lives measured in years. To think of the Earth as a mind forces a scale shift. Neurons are not lonely little creatures. They are components of a system whose identity exists only in relation to patterns of firing and modulation. Might humans, collectively and in their technologies, function like neurons do within a larger, more slowly integrating network, sending spikes of energy and information, making and breaking connections, occasionally overwhelming the system with synchronous activity? The analogy helps, and it misleads. It helps because it gives form to a difficult thought. That agency does not require intention in the human sense. It requires organization across parts with mutual influence and memory. It misleads when the metaphor is taken literally, conferring personhood to rocks and storms. The planet does not have a form and hidden beneath the crust, yet it hosts processes that resemble sensory transduction, integration, and long-term memory. Plate tectonics, ocean circulation, the carbon cycle, the geomagnetic field, and microbial biospheres are not inert machinery. They are a web of interactions that sample conditions, transmit changes, and alter probabilities for future states. In function, not in interiority, they do some of what neural tissue does. If humans are akin to neurons in that network, then their collective activity is simultaneously a signal and a perturbation. Cities pulse with energy use, supply chains root matter and heat across oceans. Radio waves and satellites knit a fast-moving technosphere through which information flows with latencies measured in seconds. The Earth's timescales, however, are measured in millennia. The slow sealing of carbon into carbonate rocks, the patient creep of a subducting slab, the accumulation of isotopic signatures in crystals that survive eons of recycling. For an organ to be aware of its cells, its sensory apparatus must bridge those timescales. It must integrate rapid spikes over time into patterns that matter at the scale of the whole. Could the Earth observe in that way? Observation, strictly defined, is the registration of change and the retention of that registration. On that minimal account, yes, the planet records and responds. A volcanic eruption alters atmospheric chemistry and climate. A reforestation program changes albedo and local hydrology. A bloom or phytoplankton redistributes carbon. These are observations of sorts, consequences that are registered in the coupled systems, and that change their trajectories. The more intriguing question is whether those registered changes constitute a form of information processing that resembles observation with a functional aim, not merely a causal chain. Do the planet's systems integrate localized perturbations, weigh them against prior states, and steer future dynamics in ways that sustain coherence? Science can approach this by identifying modes of coupling and persistence. A biosphere that modulates atmospheric composition through metabolic fluxes, think of oxygenation or methane production, is a driver of planetary boundary conditions. When these biological activities collectively feed back on climate and nutrient cycles, they produce long-term trajectories that are not reducible to any single organism. The resulting patterns are history-sensitive. Past activity influences current states, and current states influence future possibilities. That is the core of what cognitive theorists call memory and state dependence. Whether this suffices to say the planet observes depends on how one defines the minimal cognitive apparatus. If cognition is considered strictly neurocentric, the answer is no. If cognition is broadened to include integrated, history-sensitive systems that modify their own conditions of existence, then the Earth, through its web of feedbacks, engages in a kind of planetary registration. Second turn of the question concerns the planet's speech. Can the Earth communicate to humanity through natural changes, storms, droughts, the slow retreat of glaciers, in a manner that is interpretable as message rather than pure physical consequence? Here again, the narrator must walk between two temptations, mystical projection and cynical dismissal. Natural changes are neither messages sent from a mind with intentions nor random, uninterpretable noise. They are events within physical systems whose changes carry affordances and constraints for living beings. The distinction worth keeping is between causal effect and communicative meaning. A hurricane is not intentionally scolding a city. It is redistributing heat and angular momentum according to meteorological laws. Yet the human social world reads that redistribution as meaningful. It carries cost, loss, and imperative. In that sense, natural changes speak through consequences by altering the conditions that demand human response. Language matters here. A message implies an agent, a sender, and an audience. What is more productive is to think of planetary signals, complex, often ambiguous patterns of change that can be translated into human-relevant information. Ice core records speak to paleoclimatologists in isotopes and gas ratios. Satellite imagery speaks to coastal managers in shoreline recession. Tree rings speak to ecologists in moisture and temperature. These are not anthropomorphic utterances. They are material alterations that, when correctly decoded by instruments and traditions of knowledge, carry the story of cause and consequence. The planet's repertoire is vast. Pulses of methane, shifting currents, coral bleaching events, anomalous heat content in the abyss. Each is a variation in state that humans may treat as signal when they have the interpretive frameworks to do so. That interpretive work is as much cultural as it is technological. Indigenous peoples have long read environmental cues as communicative signals, the timing of bird migration, the smell of thawing earth, the behavior of certain plants, and have embedded those readings into practices of stewardship. Modern science produces other grammars, thermodynamic budgets, isotopic signatures, and coupled climate models. Both modalities are necessary. Where indigenous knowledge offers intimate, place-based sensitivity to rhythms and anomalies, science offers scaling and systematized inference. Together they form a richer translational apparatus for hearing planetary signals. Yet there are profound obstacles to successful translation. The Earth communicates mostly on timescales that outrun political attention and market horizons. Signals are noisy and multiplexed. Local events are entangled with remote causes. A drought that collapses a harvest in one valley is bound up with teleconnections that reach to distant ocean temperature anomalies. Human social systems, governed by quarterly accounts and electoral cycles, can misread slow warnings as market volatility or moral panic. Worse, the human technosphere often amplifies certain signals while muting others. Industrial land use changes can hide the soil's loss of resilience until a single extreme event reveals it catastrophically. The practical upshot is unambiguous. If the Earth speaks through physical change, humanity needs better ears, deeper vocabularies, and institutions able to act at appropriate tempos. Listening is an art and a practice. It is not the passive reception of data, but the cultivation of attention, the development of instruments, and the design of political architectures that convert slow signals into accountable decisions. What, then, should be recommended? If the speculative frame is useful, whether or not one grants the planet literal sentience, the moral architecture that emerges is clear. The following recommendations are not metaphysical prescriptions. They are pragmatic priorities that would sharpen humanity's capacity to understand the planet's feedbacks and to act responsibly within them. Build a global system of planetary listening that integrates diverse senses and knowledges. Expand and knit together long-term observational networks, satellite constellations for remote sensing, ocean float arrays for heat and carbon, dense soil moisture networks, expanded seismic and geomagnetic monitoring, and deep borehole observatories that track subterranean processes. Complement these with social and ecological observatories, community-based monitoring of phenology, traditional ecological knowledge hubs, and participatory data platforms that democratize access to information and ensure local voices feed into global syntheses. 2. Treat planetary signals as public goods and open data. Ensure that climate, hydrological, and biodiversity datasets are interoperable, publicly accessible, and maintained beyond electoral cycles. This reduces interpretive bottlenecks and allows civil society, researchers, and local managers to read signals in concert. 3. Institutionalize long-term stewardship with mechanisms for intergenerational accountability. Create durable institutions, trust funds, stewardship councils, chartered agencies with legally mandated time horizons of multiple decades that can act on slow signals and resist the short-term capture of political economies. Embed precautionary thresholds into decision rules when systemic risks of irreversibility appear likely. Default to conservative management and reversible interventions rather than speculative fixes. 4. Prioritize the protection and restoration of the biogeochemical engines that mediate planetary feedbacks. Conserve and restore wetlands, mangroves, seagrass beds, old-growth forests, and soil organic matter. These systems sequester carbon, buffer hydrological extremes, and host microbial processes essential for planetary homeostasis. Protect microbial diversity and integrity in soils, sediments, and oceans. They are foundational workers in the planetary metabolism and are vulnerable to chemical and physical disruption. 5. Reconfigure energy and material systems to reduce perturbation amplitude. Rapidly decarbonize energy systems, halt new fossil fuel infrastructure, invest in renewable energy storage and equitable transmission. Shift agricultural systems toward regenerative practices that rebuild soils, retain water, and sequester carbon at scale, reducing the need to manipulate planetary stocks abruptly. 6. Invest in anticipatory, equitable adaptation and resilience. Support infrastructure and social programs that reduce vulnerability to known signals, sea level rise, heat waves, droughts, while maintaining flexibility to respond to novel events. Prioritize the needs of the most exposed populations and ecosystems. Justice is integral to planetary care. 7. Regulate the technosphere's expansion with an ethic of containment and reversibility. Develop governance frameworks for emerging planetary-scale technologies, carbon removal, solar radiation management, geoengineering, that require robust assessment, democratic oversight, and demonstrable reversibility before deployment. Resist solutionism that treats technology as a substitute for emission reductions and ecosystem protection. 8. Foster cultures of long attention. Integrate deep-time literacy and systems thinking into education, media, and civic rituals. Create public calendars and narratives that celebrate slow rhythms, seasonal migrations, river pulses, soil renewal, so that citizens learn to value persistence and patience, support arts and communication practices that translate slow signals into compelling, non-alarmist stories that motivate sustained action. 9. Expand research into integrative metrics without leaping to metaphysics. Fund interdisciplinary work on system integration, information flow, and resilience metrics that can clarify how coupled Earth systems register change. Such research should be explicit about limits. Formal measures of integration are analytic tools, not proof of subjective interiority. Use these metrics to identify early warning indicators, not to make ill-founded claims about planetary consciousness. 10. Honor and integrate plural epistemologies. Create legal and funding mechanisms that support indigenous stewardship, local ecological knowledge, and community custodianship alongside scientific research. Co-design monitoring and governance produce better translation of signals into action. 11. Plan for repair, not restoration. Accept that past baselines will often be unreachable. Prioritize the construction of functional, biodiverse systems under new boundary conditions. Repair is craft. Reconnect rivers to floodplains, rebuild soils, and allow space for ecological migrations. 12. Cultivate a moral imagination oriented to reciprocity. Move from narratives of mastery and extraction toward narratives of mutual reliance. Emphasize practices that rebuild gradients, nutrient cycles, hydrological connectivity, and habitat heterogeneity, rather than flattening them into efficiencies that fail under stress. These recommendations flow from a single humble premise: whether or not the Earth observes in any anthropomorphic sense. It is an integrated system that will respond to human activity according to its physics and chemistry. To act with the assumption of being mere guests on an inert stage is foolish. To claim one can bargain with the planet as if it were a moral agent that will forgive recklessness is dangerous. The ethical posture that follows is not mystical reverence but disciplined care. If humans are, in some functional analog, elements in a larger body, then their choices matter not just for themselves but for the ensemble dynamics that enable any complex life. Listening becomes an infrastructural task, instruments to measure, institutions to steward, cultures to sustain attention, and policies robust enough to act when slow signals indicate systemic shifts. It is also a moral practice to recognize limits, to value repair over consumption, and to align power with responsibility. In the end, the most practical way to answer whether the Earth is observing or speaking is to behave as if it both remembers and responds. That posture is conservative scientifically and generous ethically. It aims neither to collapse metaphysics into policy nor to use uncertainty as an excuse for inertia. It places humanity in the posture of a caregiver whose own nervous system is quick and whose hands are large, careful, slow, and intent on keeping the body they touch alive for more than a single lifetime. What if the ethical posture of a civilization were not a philosophy paper nor a policy memo, but a habit of the body, a repeated, practical way of moving through the world that assumed the ground beneath one's feet was living tissue? That idea is small enough to be held in a single breath and large enough to demand new institutions, economies, and rituals. It reframes the ancient question that opened this series. Whether Earth thinks or not is less immediately decisive than the manner in which a species chooses to orient itself toward a massive, history-rich, partly responsive system. The final act of the documentary is not a definitive answer about planetary mind. It is an extended argument for an orientation of care, to live as if humanity dwelt inside a body that required respect, preservation, and collaboration rather than extraction and domination. The voice that carries this argument is neither judgmental nor sentimental. It is practical and ethical at once. It begins with a simple image: the hand that tends a wound. In ordinary life, tending implies diagnosis, modest intervention, a respect for the patient's rhythms, and an acceptance that healing is often slow and incomplete. Applied to a planet, the same posture asks for diagnostics, listening carefully to signals, modesty, prioritizing reversible interventions, attunement, working with existing processes and communities, and patience, measuring success across decades and centuries. Each of those commitments breaks against prevailing habits of speed, profit, and political immediacy. They require cultural recalibration as much as technological innovation. Emotion sits at the core of this transformation. Across cultures and histories, the collective mix of feelings toward the planet has been ambivalent: wonder and pride, indifference and contempt, guilt and resignation. Those effects map onto behavior. Wonder can enlarge perspective. Producing humility and stewardship, shame can immobilize or catalyze repair, fear can precipitate either panic or disciplined preparation. The ethical project here is to convert raw affect into socially productive orientations, to translate awe into policies that preserve diversity, to turn shame into reparative action, to shape fear into precautionary governance rather than fatalistic retreat. To make this concrete, the documentary voice draws attention to the anatomy of care at multiple scales. At the immediate scale, the equivalent of tending a skin lesion or a bruise, the practice begins in household economies and municipal planning. It looks like water-sensitive urban design that treats runoff as resource rather than waste, like rooftop. Gardens and permeable pavements that feed soils while cooling streets, like sewage systems retooled to recover nutrients rather than merely to dispose, like local energy grids that favor permanence and community ownership over distant extractive projects. These actions are small, but they accumulate. They are the equivalent of cleaning a wound, applying a dressing, and returning to check on it. At the landscape scale, care implies managing flows rather than walls. Rivers are not infrastructure problems to be tamed into neat channels. They are metabolic arteries that carry sediments, nutrients, and memory. To live as if inside a body means reconnecting rivers to their floodplains where possible, protecting wetlands that act as kidneys and filters, and resisting the temptation to harden coasts in ways that create perverse, brittle resilience. Sediment is not debris, it is tissue. The slow work of restoring river corridors, allowing meanders, re-establishing riparian forests, removing unnecessary levees is restorative medicine for basins that have been overdrafted by industrial agriculture and short-term flood control. At the regional and planetary scales, the posture of care becomes governance and economy. Fiscal and legal structures must internalize long-term environmental costs rather than externalize them. That requires redesigning incentives, carbon-priced, in a manner that reflects the social cost across generations, subsidies shifted from depletion to regeneration, legal frameworks that grant standing to ecosystems and future cohorts, and investment rules that prefer long-lived infrastructure and ecological restoration over extractive short-term yields. This kind of reconfiguration resists the present politics of immediacy. It insists that markets be instruments of stewardship rather than engines of one-off extraction. A radical element of this posture is the elevation of collaboration over control. The logic of exploitation assumes separability, that the human system is independent and can safely manipulate the planetary subsystem to its advantage. The logic of collaboration recognizes integration and contingency. Actions ripple across coupled systems in ways that are rarely local or linear. Collaboration implies new institutional forms, polycentric governance networks spanning local, regional, and global scales, treaty mechanisms with teeth and time horizons measured in centuries, and rights-based frameworks that provide legal recourse for ecosystems and future peoples. It also means revalorizing local and indigenous governance structures that have evolved practices of reciprocity with place. Those traditions are not quaint. They are adaptive technologies of long-term relationship. A core moral argument returns persistently: precaution. When dealing with a body the scale of a planet, some harms are irreversible within humanly relevant timescales. The loss of a major ice sheet, the collapse of a coral reef system, the release of large stocks of methane. These are not small experiments. The precautionary stance is not anti-innovation, it is pro-preservation. It demands reversible interventions, robust evidence before planetary-scale engineering, and a bias toward replenishment over extraction. Where uncertainty about thresholds exists, policies should prefer reversible, restorative action and the protection of buffers that slow or damp cascades. Resilience, in this ethic, is not an appeal to mere robustness but to regenerative capacities. A healthy body is not rigid, it flexes and repairs. That suggests a new economic lexicon. Economies that invest in the renewal of soils, in the diversity of landscapes, and in cultural practices that replenish rather than deplete. Regenerative agriculture that rebuilds organic matter, reforestation keyed to native species that restore microclimates, the protection and restoration of coastal wetlands that sequester carbon and shield communities. These are investments that pay dividends on timescales longer than corporate quarters, but are essential for stability. They realign human production with planetary metabolism. The moral imagination must also transform everyday rituals. Rituals are cultural technologies for aligning attention. Where modern life has become disembedded from seasonal cycles, Urban populations often lose the competence to notice slow changes until they become crises. Rituals that re-embed attention can be simple and profound. Community tree plantings timed to seasonal pulses, citywide energy down days tied to celebrations of light, school curricula that require hands in the soil practices, and markets that reward local circularity. Rituals do not replace institutions, but they create the social glue that sustains long-term commitment. They shape tastes, which in turn shape economies. A society that prizes reclaimed wetlands and diversify crops as beautiful will tend to protect them. A crucial ethical dimension is the humility to accept limits. This humility is not resignation. It is realism about scope and power. Some planetary processes cannot be commanded. They must be negotiated with. Accepting limits invites a shift from grand, hubristic projects to careful, distributed stewardship. It recenters the human role as caretaker rather than architect, managing, mending, and cooperating with systems that have independent dynamics and long temporal horizons. Humility thus becomes a policy stance, to refrain from geoengineering hubris until governance, moral, and evidential frameworks are robust, to prefer distributed solutions that build local capacity over centralized techno-fixes that risk systemic failure, and to invest in knowledge systems that expand patience. Knowledge is itself an ethical practice. The act of listening, advocated in earlier chapters, transforms into concrete epistemic responsibilities. Long-term monitoring networks must be maintained not as optional scientific curiosities, but as civic infrastructure. Datasets must be public, interoperable, and curated for longevity. Paleoclimate archives must be expanded, microbial diversity inventories made robust, and social science investments in how communities adapt and remember must be normalized. Listening requires instruments, satellites, floats, boreholes, and people trained to translate those signals into socially legible narratives. The moral hazard is to reduce listening to technical surveillance. The moral imperative is to make listening participatory, transparent, and accountable to those most affected. Justice figures centrally in this framework. A planet cared for unevenly produces unjust outcomes. Vulnerabilities are not metaphysical, they are political. The communities suffering first and worst from sea level rise, extreme heat, and disrupted food systems are often those who contributed least to global emissions. An ethic of care therefore implies redistribution of resources and agency, financing, adaptation, and restoration where historical responsibility and current vulnerability intersect, ensuring technological transfers that enable low-carbon pathways for development, and empowering local governance over land and resources. Justice is not merely compensation, it is transformation of who makes decisions and who benefits from the shift towards stewardship. The documentary voice insists that collaboration must extend beyond the human. Microbial systems, soils, forests, and oceans are co-stewards in the sense that their functions determine resilience and habitability. Practices that respect the body recognize that human welfare is embedded within the fitness of other organisms. That recognition has technical implications. Protect microbial diversity in soils and sediments. Avoid blanket sterilization that eliminates essential services. Favor land uses that maintain ecological corridors for species migration, and treat wildness as a functional partner rather than an obstacle to development. Culturally, this philosophy requires new stories. The dominant myth of endless growth must be replaced by narratives that celebrate sufficiency, craftsmanship, and long-term relationships. Stories of industry and conquest have historically mobilized resources effectively. Stories of stewardship must now perform the same mobilizing function. That is partly an aesthetic task, reframing the beautiful to include heterogeneity, messiness, and functional complexity. It is also political, design incentives, and educational systems that valorize repair, maintenance, and the skills needed for regenerative economies. The final ethical commitment is intergenerational fidelity. To inhabit a body is to be responsible for its future states. Institutions must be retooled to hold obligations across centuries, public trusts for environmental assets, legal representation for ecosystems, constitutional protections for basic planetary services. These are not utopian fantasies, but governance challenges, setting aside sovereign wealth funds dedicated to restoration, embedding guardianship principles into law, ensuring that political turnover does not reset commitments to future cohorts. Intergenerational fidelity transforms short-term political bargains into long-term caretaking covenants. At the tonal center of this argument is a form of hope, different from naive optimism. It is a hope conditioned by realism, the conviction that human capacities for learning, invention, and solidarity can be marshaled when the stakes are made proximate, when institutions reward patience, and when ethical practices become habitual. It is not a belief in easy salvation, but an assertion that purposeful, collective action can alter trajectories. The body metaphor gains force here. Wounds heal poorly when neglected, but they often heal when tended with humility, competence, and persistence. The narrator closes with a reflective injunction. Whether Earth is an animate mind or a collection of coupled processes, the relevant fact for moral life is that human agency is embedded inside a system of dependencies. To live within that system with integrity is to adopt an ethic of care, to reduce harm, to restore function, to collaborate with fellow species and with future persons, and to design institutions that translate the slow mathematics of geophysics and ecology into policies that endure. This ethic asks for courage, the courage to defer consumption for future steadiness, the courage to reorient economies and taste towards sufficiency, and the courage to accept small, patient victories rather than grand, immediate triumphs. If a body requires nursing, the work of nursing is ordinary, repetitive, and relentless. It is not glamorous. It is the checking of levels, the mending of tissues, the feeding of systems in ways that sustain the whole. To live as if inside a body needing care is to make nursing the central civic profession. Policymakers who think in centuries, farmers who tend soils as sacred trusts, engineers who design with reversibility in mind, cultures that ritualize attention to seasonal and planetary rhythms. That ethic of care is not a retreat from complexity, it is an embrace of it. In the hush, after these reflections, a quieter question remains: what kind of species will choose this posture? The answer is not predetermined. It is a collective decision, woven from policy, practice, ritual, and imagination. The documentary reduces none of the difficulty. It insists only that the act of choosing, to exploit or to collaborate, matters in real time. The earth will continue its rhythms, with or without human consent. The ethics of inhabiting this planet asks that humans decide now whether to be nurses at its bedside or tenants who ignore code and wonder why the house has a fever. The narrative does not demand belief in a planetary mind. It asks for fidelity to a simpler, more urgent belief that living inside something large and fragile confers duties that transcend short-term gain. In that vow to respect, preserve, and collaborate, there is a moral architecture robust enough to guide action through the deep times that follow.